So we shall continue from where we left off. So I know that some students might be there and they might be there from batch 3. Good afternoon. So if the first segment might be a revision to you, okay, the first part alone, because we're going to continue from tropical cyclones. Okay, so just hold on for the first 30 minutes. If anyone is from batch 3, for them it might be a continuation. Okay, for B7, we're just continuing from where we left off. We were discussing tropical cyclones in the previous class, right? So we just need 10 more minutes. We just complete tropical cyclones. We're just going to discuss about India, when do tropical cyclones occur over India and why certain states are selectively affected. And after this, regarding tropical cyclone decay. Okay, with that, the topic will be closed. Is it okay? Now, after this larger section of today's lesson plan, we'll discuss about jet streams. It's a very powerful atmospheric phenomenon which takes place in the upper atmosphere. Then air masses. After air masses, extratropical cyclones or temperate cyclones. Extratropical or temperate cyclones. Once you finish temperate cyclones, we need to compare both of them. Comparison of tropical and temperate cyclones. Once comparison is over, we'll try to attend a mains question today. We haven't discussed how to attempt main questions, no? So we'll try to attend a mains question. Like we'll try out a question, how to approach the answer, what is the right way to write, and what UPSC expects. Okay, so this is the first half of the class till 4:30. Okay, 5 to 7:30 we'll see later. Fine. How to draw a map, I'll teach you today. No worries. How to draw a map? Yes. Today we will see. Okay. I can't teach you beautiful maps, but I can tell you what map is required for exam. That we will see. So let's continue with India, where we left off. See, the reason why India is different, first understand that India, the movement of tropical cyclones is slightly different. It is not governed by your trade wind system because India experiences monsoon climate. So over the Indian subcontinent, monsoons are the controller. Over India, monsoon wind systems dictate the movement of cyclones. Dictate the movement of cyclones. Okay, it's slightly different. So let's take two different parts. We'll take our summer season and southwest monsoon, winter season and your north monsoon, and we will discuss the reason why certain states in India experience more cyclones compared to the others. Is it clear? Very simple discussion. Yeah. Now, if you look at the states which get affected by cyclones most frequently, it is the eastern states. Okay, I think Varna Bhagwan has some problem with the states West Bengal, Odisha, Andhra Pradesh and Tamil Nadu. It is these states which have the most number of cyclones. You don't have many cyclones in Gujarat, Goa, Karnataka, Maharashtra and Kerala. So why is the reason? Let me draw cyclonic systems both ways, okay? So let's say we have a cyclonic system in both my, okay, summer, southwest monsoon time period, or winter, northeastern monsoon time period. Now, this is when you understand about the frequency of occurrence. Tropical cyclones occur more during winter. Why do they occur more during winter? Think back to one of the properties of water, differential heating of land and water. So, on an annual time scale, compared to your continents, if you take your water bodies becomes warmer or the sea becomes warmer only during your winter season. That is when the surface temperature or sea surface temperature is very, very high. Okay. So if you look at the frequency of cyclones or the occurrence of your tropical cyclones, it is more in your winter seasons. You get more number of cyclones here. Is it okay? You get the idea, more and more depressions. Now, in the winter season, the dominant wind system is your northeastern monsoon. So this is my northeastern monsoon. Is it clear? So if you look at the direction of northeastern monsoon, the monsoon winds, start from the central portion of India, northwestern portion of India. They move towards Bay of Bengal and this is the direction they take. This is my northeastern wind system. Is it not? That is why the eastern states of India have very high occurrence of cyclones. They are much more cyclone prone. Is it okay? Northeastern monsoon. This is my direction. So idea is this: winter season, more number of cyclones, and during winter season there is northeastern monsoon. So naturally winds will blow from eastern side to western side and attack the eastern coast of India. Western coast is much safer. But in some cases, that's why, right? Okay, most cases. In some cases, very rarely, okay, you might get sea surface temperature or certain localized parts of the Arabian Sea and Bay of Bengal might be warmer. So this is my southwestern monsoon. Okay, it comes immediately after summer. So this is rare chances, rare cases. In those cases, the cyclone might come and hit your western portion of India. But please know this is quite rare. Why? Because during your summer season, it is your land which is hotter. Okay. So it's not that Varna Bhagavan has some problem with the 4 states. It is more to do with geography again. Seasons, that's it. If you finish the diagram, use the word finished. Doubt is clear? Now it's okay. So you yourself can pinpoint which state will be more cyclonic prone. More cyclones during winter season. During winter season, northeastern monsoon is there. Northeastern monsoon, eastern side to western side. So only the eastern part of coast or the eastern coast is mostly affected. This is a rare chance. That is where rarely Kerala might get, rarely your, Gujarat might get a cyclone. That happens like once in 15 years, once in 20 years. These cyclones in Odisha, Andhra Pradesh, every single year you get at least 2 or 3. Is it okay? Chennai should receive this year. Like we only got depressions. We haven't got cyclones, right? Last 4 years, we haven't got a severe one. Last was 2016. Were you there in 2016? 16, Varda. Varda was a very powerful cyclone. In summer, what happens? See, please understand, the point is there. You want me to write the point here? Go to properties of water in your notes. Look at differential heating of land and water. Then I can only write it very explicitly. Based on the property differential heating of land and water, during my summer season, land is hot, water is cold. If water is cold, you cannot form a cyclone. Why? Cyclone is a heat engine. Is it not? You need high sea surface temperature for forming a cyclone. Shallow water bodies with temperatures greater than 27 degrees Celsius. At the end of the day, this is what I do. You want me to spoon feed, I will spoon feed. Something which is already there in your notes, people. Nothing new. Is it okay? It's there. Any doubts, just look at your properties of water. Shall I proceed further? Yeah, something which has already been given to you is what extent. Nothing new today. Now proceeding further, it's about cyclonic decay. We have seen about formation, we have seen about mechanism, how the spiral comes in, rises vertically, divergence, convergence, adiabatic compression, adiabatic expansion and all that. How does this cyclone die? See, the cyclone decay is mostly based on 2 factors. Okay, the second factor is pretty almost limited. It's the most important factor. What happens if the cyclone comes to land? Okay, so let's say this is my land and this is my sea. My cyclone. Okay, this cyclonic system is forced by this trade wind system, right? So let's say the cyclone keeps moving. Over a period of time, the cyclone comes here. Okay, so after consistent push, trade winds continue to push. And after, let's say 5 days, 10 days, slowly the cyclone has moved towards land. See, point you need to understand here is, okay, cyclone is essentially circulating, so anti-clockwise direction. Okay, essentially circulating primarily because of latent heat. And where does latent heat come from? Latent heat comes from extra amount of moisture. Moisture prevalence is present in your large water body. Let's say if you are present in the center of Bay of Bengal, wind systems from all those directions will come towards the center of the low pressure system. So large number of winds will, provide you large amount of moisture. You are in the center, surrounded by water. Now, same cyclonic system from the center of Bay of Bengal, let's say you're pushing it towards Tamil Nadu. Okay. Now, see what happens. One section of the cyclone has already reached land. Now, in this segment, you see that once you come towards land, naturally moisture supply gets cut off. Moisture supply gets cut off. So once the moisture supply gets cut off, fine, it's like a circulatory system. See, if you cut one half of my body, okay, this is only one segment, you might argue, but if you cut one half of my body, will one more segment of my body survive? Not possible. Like, it's an integrated system. The circulatory system, nervous system, muscular system, skeletal system, everything works together. And we are talking about something like a circulatory system. You cut one half of the cyclone, okay, you deprive moisture for one half of the cyclone, naturally there is no latent heat. You're affecting latent heat composition. No latent heat is there, or reduced amount of latent heat, slowly the cyclone will decay. See, that is why whenever they use this terminology, the cyclone will make landfall at 5 p.m. on November 27, 2020. So this process, the cyclone entering land, is called as landfall. That is why whenever there is landfall, you make landfall, within few hours, 2.5 to 3 hours, the cyclone will die. Okay, they will use this terminology. The cyclone made landfall and slowly it began to dissipate. Why it dissipated? Due to absence of moisture. That's it. I want to show you something. This is how most cyclones in the world work. Tropical cyclones, or hurricanes, or typhoons. Okay. Got a doubt on how depressions and low pressure systems form in sea? Please give a hint. Is there in your notes yesterday? Please go through it. Please go through it. If there is still doubt, please ask me at the end of the class. I've given you 3 conditions on why they form. Yesterday we discussed this intensely. At times, don't bowl that ball at 2:20 when the class is starting. Okay. Shall we proceed further? Use the word finish if you're done, if you've understood. Yeah, you don't have moisture, you're done. That's it. Yeah, thank you. I want to talk about one cyclone which devastated parts of Tamil Nadu. The name of the cyclone is Gaja. Gaja is elephant, no? Yeah. You know what the cyclone did? See, again, note, this is an exception and not an example. Exceptions cannot be examples. But if someone asks you about Gaja cyclone, you should be in a position to explain. Hold on. Yes. I think this is a better map. Yeah, this is much better. What did I teach you? Cyclone comes into land, what should happen? Cyclone should die. Look what cyclone Gaja did. Gaja starts in Bay of Bengal, keeps moving. What should have happened is, after reaching this end, okay, let's say it is reaching Chennai and Pondicherry, the cyclone should, okay, it was close to Kadalur, yeah. Once it reaches Kadalur, then the cyclone should die out. Extreme chance, okay, very, very rare chance occurred that year when Cyclone Gaja was there. Cyclone Gaja started walking on land, crossed Kerala, then went into Arabian Sea. This is an exception. Rarest of rare case, this is not an example. So anyone asks you, well, you just say the tropical cyclones will die on land, but Cyclone Gaja did not happen. Cyclone Gaja proceeded over land. In very, very rare chances, okay, if the size of the cyclone is big, if it is extremely strong, okay, then it will be in a position to pass through. So this is an exception, not an example. 2018, yeah. It brought a large-scale destruction to coastal areas, actually, not just coastal areas, but also here. Kadalur. Kadalur is in central eastern Tamil Nadu, eastern coast. Okay. How did Gaja made it over land? That's what I'm telling you, Nishit. It was a very powerful cyclone. It's an exception. Please note, it is an exception. That is why I clearly mentioned it's an exception. Okay. Will there be heavy rain during decay? If so, why? There will be heavy rain during decay. Yes. Okay. If so, why? If so, why? Because, again, understanding. Hold on. It's not the right way to approach it. Hold on. Let me explain. It would have been much better if you were in the classroom. Okay. Through the chat box is really not helpful. Please wait. Raj, I just now told you trade winds. Please don't make me do that again. I'll read the question for you. You yourself look at the question. The movement of the cyclone is dependent upon trade winds, right? I told you in India doesn't work. I told you India it's monsoon climate. I have clearly used the word here. I don't know what is the problem. I started with that. Look at the word right there. Over India, monsoon wind systems dictate the movement of cyclones. You frame the question based on the assumption it is trade winds. What do you want me to answer? It's right there on the board. Oh man. Next question. See, next time you post the question, you better be careful. You check your notes and then post a proper question. This is not the right way to ask questions. Okay. Is a cyclone destructive in middle parts of lands where there's lack of moisture? Rishi, the velocity of Gaja actually reduced. The velocity reduced, but the cyclone was able to proceed further. Its speed reduced down. It definitely brought down. Okay, but it was not. It was able to proceed. Destruction was maximum in the coastal areas. Then it went on here. This is the eye. Okay. Let's say a place is here. This is the area which receives cyclone. What most people miss the idea is the question that came is this: cyclone is already decaying, then how will high rainfall be there? Cyclone, yes, cyclone is decaying, but please understand when the cyclone approaches, the land area which is marked as X will be exposed to more and more areas of high velocity winds and more cumulonimbus clouds. Amount of cumulonimbus clouds will be very, very less here. If the cyclone comes in, you will be inside the cumulonimbus wall. This will bring in more rainfall. If it comes even more, this section will be even more exposed. Okay. So two processes happen simultaneously. As the cyclone moves in, you're getting exposed to more and more regions of high rainfall areas of the cyclone. At the same time, cyclone will slowly dissipate. Okay. Extremely rare chances this section might come in, but before the eye comes in, this entire segment will go. Please understand, velocity is maximum near the eye of the cyclone. It's very, very high. This is where, like, just outside the eye is where you get the maximum rainfall pattern and highest velocity of winds. So at the external surface, the velocity is very, very less. You bring it up here, you're bringing in region of a high velocity and high rainfall region. So natural rainfall will be high. Is it okay? So two processes happen simultaneously. Person who asked this question, is it fine? Just let me know. Will there be heavy rain during decay? If so, why? Is it fine? Make it faster. Yeah, fine. Next segment. Copied? Yeah. So this is the one segment which we needed to discuss about decay. Second part is not exactly cyclone decaying. There are two factors which help the formation of cyclone and inhibit the formation of cyclone. If you had noted the discussion well, in the definition I would have given you, tropical cyclones form between the latitudes of 5 and 25 north and south. So why 5 and 25? Why can't they form an equator? That is where we're going to discuss. Okay. Did I tell you about Coriolis force maximum minimum? Why it is maximum in the polar region? Why it is minimum in the equator? Check your notes. Go to Coriolis force. Not checking the notes. See, 4 months later, you will ask me, okay, what is cyclone? Okay. Was the eye of cyclone being experienced when Gaja passed in the land? Yes, man. Entire cyclone passed. Now I will also come in. What question is that? Hmm? Under Coriolis force? No. Okay. So decay number 2, okay, or destruction or inhibition of a cyclone. Cyclones don't form an equator. Cyclones will form slightly away from equator. We want to understand the reason why. Fine. So for that, we go to Coriolis force. Coriolis force is maximum in the polar region. Maximum in the polar region and minimum or almost nil near the equator. Fine. Simple reason. If you missed the Coriolis force class, you better don't ask questions. You better watch that video, then come back. If you listen to Coriolis force class, then you pose any question in case you have a doubt. Equator, 90° north, 90° south. Think back to discussion of Coriolis force again. Coriolis force is an apparent movement. It is caused by rotation of the Earth. And if you remember the discussion, Coriolis force was simply a result of change in radius. As any object moved between different parts of the Earth, it was experiencing difference in radius. And that is the reason there was more and more deflection. So if I can say that during movement, listen carefully, if I can say that during movement, the radius change experienced is less, then naturally deflection will be less. Let me take a location near polar region. If you draw the radius of the circle, let's say 85° north, this will be the circle. Let's say if you're in 45, this will be the radius of the circle, right? So if you look at this region, as you make the movement between 45 to 85 or 85 to 80, you are actually changing the radius rapidly. There is large change in radius. Large change in radius. So if there is going to be very big change in radius, then deflection will be high or Coriolis force will be high. Deflection is high. You come to the equator, it doesn't happen. Why? Let me draw the radius again. You between 0 and let's say you take 5. Okay, these latitudes, the radius is almost same. It's not that change is non-existent, but the radius is not really significant to be accounted for. Okay, so less change. Since there is less change in radius, less change, very low Coriolis force. Very low Coriolis force. Is it clear? Larger deflection, larger radius change, larger deflection, larger Coriolis force. Less change, less Coriolis force. Okay. You show the path of the cyclone, so it is the path of eye of the cyclone. Yes, yes, yes. Finished. Now what we'll try to do is we'll try to connect this point with reference to cyclone formation. Okay. Hold on. Yeah. In the equator, Coriolis force is very less. Let's say it's approximately equal to 0, even though it is not. Very, very low. Approximately equal to 0. Which means if there is a high pressure system, if there is a low pressure system, pressure gradient force will try to come and fill this low pressure. Understand the circulation was about to start and the velocity increased for formation of cyclone only because Coriolis force deflected towards the right side. You saw the diagram yesterday. So only since Coriolis force is there, deflection will happen. Now look at the condition right now. Coriolis force is 0. If Coriolis force is 0, then this force is not absent. You take out this Coriolis force, then pressure gradient force will be easily able to fill this location. Once you come and fill this location, the low pressure system is filled, cyclone dies. Meaning makes sense. So as Coriolis force is 0 or approximately equal to 0, the low pressure system gets filled. Low pressure system gets filled. So cyclones do not form close to equator. You at least need a latitude of 5 to initiate the rotation. Cyclones do not form close to equator. Can we say due to less wind flow in equator, Coriolis force is less? No. There is less wind flow in equator. That point is correct. But that is not the reason why Coriolis force is 0. Fine, your interpretation, like one part of the statement is right, but the assertion is not the reason. Okay. First statement is correct, but that is not the reason for Coriolis force being less. Coriolis force is less because change in radius is negligible. Shall we proceed to the next point? Last point before we close. Then we move to jet streams. Okay. Just let me know. Yeah, thank you. Because if they frame any statements, please don't get confused. You will get 2 or 3 statement questions in your prelims only like this, and you might make some fundamental errors. See, idea is ITCZ is actually a system which will help in the formation of cyclones. Why ITCZ? Think back to notes. Under properties of pressure belts, you would have written about ITCZs. The zone of low pressure belt where there is vertical movement of air. You at least remember the diagram where I drew 2 ships. This ship will move, this ship won't move. Yeah. See, understand, ITCZ is nothing but a proper area which will help in movement of low pressure. There is vertical movement in ITCZ. Look at the structure of cyclone. Structure of cyclone also I have written the same thing. Cyclone is moving. The diagram you had copied yesterday. So ITCZ helps in the formation of cyclones. Helps in the formation of cyclones. Wait, let me finish. Because it enables vertical movement of air. Wind moves up. Not wind, sorry, air moves up. Wind is always horizontal motion. Taken. We want to link ITCZ and Coriolis force. ITCZ and equator, that's why. Yeah. Don't get confused between equator and ITCZ. Equator is a constantly located imaginary line dividing the earth into 2 equal parts. This is equator. This is not going to change. It will remain in the same position. ITCZ is not like that. ITCZ can be north of equator because it's after all a pressure belt, and pressure belt will shift between seasons. ITCZ can be south of equator. ITCZ can be on the equator also. All possibilities are there. So, when ITCZ is quite north of equator, it will create cyclones. Cyclone formation will be there. Condition 1. ITCZ is south of equator. Number 3. It can help in cyclone formation, no problem. But even if you place ITCZ exactly at equator, let's say you cause immense amount of heating, large amount of vertical upliftment, cyclone will never form because Coriolis force is absent. So cyclone is destroyed. You can never form cyclone and equator even if ITCZ is there. Always remember the difference. ITCZ will help, equator will kill. ITCZ on equator also impossible. You can't form one. Okay. Scientifically not possible. It does obey the laws of physics. If at any point of time you're able to create a cyclone and equator, physics has changed. That's all. That's the only explanation. Is it fine? So that ends the discussion on a tropical cyclone. Any doubts are there? We'll take it at the last segment. Now we are moving to jet stream, shall we? Yeah, let's move to jet stream right now. Jet stream again, it's an introductory part. The influence of jet streams, impact of jet streams will be in 2 parts. One is impact of jet streams on formation of temperate cyclones. There is a certain one more second group which you'll see immediately. And second is how does jet streams influence Indian monsoon also. That you will learn in Indian geography. So first is the introductory part. I should introduce what is jet streams before we understand what is their impact. Jet streams. So under jet streams, we learn something called as a geostrophic wind. Okay, under geostrophic wind, I'll try to maximize it. Under jet streams, you write geostrophic wind. Okay. Jet streams is such, it's just a special case of geostrophic wind. So we'll understand what is geostrophic wind. I'll write the definition, you copy, then I'll explain. Winds flowing in higher altitudes experience negligible friction. experience negligible friction. Such winds when balanced by Coriolis force and pressure gradient force will reach constancy in speed and direction. Called geostrophic. Okay. Done. Let me explain and read the definition again. Please be patient. During our trade wind discussion, your westerlies discussion and global atmospheric circulation, we would have ignored one force, even though the force is very, very dominant. Of the three forces which govern wind systems in your nose, pressure gradient force, Coriolis force, and frictional force is very powerful at the ground level. Okay, think about this. Let's say a wind is moving from a high pressure to low pressure system. Wind moving at the ground level will experience contact with several surfaces. You can have natural landscapes like mountains, they can alter the wind. You might have a forest area spreading over hundreds and thousands of square kilometers. The wind will get distorted. Or it can be a system which was created by human beings. Think about buildings, think about areas of urban construction, so much area, so many regions of concrete, and wind will not be in a position to negotiate all that. So ground level friction is a very dominant force, even though we ignore it. Okay, for our simplification, when we learn the trade wind systems and westerly systems, that is the permanent wind systems. Now, what I'll do is I will take this wind. Let me take this one and place it 4 kilometers up or 5 kilometers up from the ground surface, right there. Okay. So there are three forces, PGF, CF, and friction, right? Now, when I shift it high up, you clearly see that your frictional force is slowly becoming negligible because you shift 5 kilometers up. There are not many mountains in the world which are as tall as that. Of course, yes, Himalayan mountains are taller. Their average height is average height is actually 5.5 to 6 kilometers. Okay, you go to Andes mountains are slightly shorter. Maybe it'll come around 4.5 to 5 kilometers. But apart from them, most parts of the world, if you look at the average elevation is low. So you shift the wind slowly up, friction won't be there except for some parts of the world. Okay. Always it is difficult when you talk about a three-body problem. Now we are not talking about three forces, now it's only two forces. So if two forces are operating, there are more chances of balance getting obtained. Balance. What balance are we talking about? See, listen. High pressure. Let's say there is a low pressure system. Wind will naturally move from high pressure to low pressure system, right? So this is done by pressure gradient force. Coriolis force acts towards the right side. Okay. Let's say if there is perfect balance. Perfect balance is an ideal condition. Let me repeat it. It's a very ideal condition, but assuming perfect balance, theoretically, the resultant will keep moving in this direction. This one. Okay. Pressure gradient will still operate. Coriolis force will continue to operate. Okay. Right side. It will continue to operate. Okay. Low pressure. Right side. And it keeps on moving. At one point of time, there will be perfect balance. Okay. And this blue color line is your geostrophic wind. Geostrophic wind. Okay. Theoretically possible. In reality, you don't find a perfect geostrophic wind, but theoretically, yes. So when PGF and Coriolis force begins to balance each other, we get this blue color line called as geostrophic wind. Always remember, the wind is not moving at the ground level, it is moving in upper altitudes. Okay, high up. Is it fine? Okay. Just a second. Sindhya Ashoka. Okay, the signal is good from our side. I just asked even now. CID, Sindhya Ashoka 2070227. Okay, maybe in case you feel the signal is low, just reconnect. Okay, just log out and then log in again. I think you should be fine. I'll just talk to the slide before this. This one. Okay. Always remember this. This wind is not at the ground level. The wind is top level. Can be 3 kilometers, 4 kilometers, 5 kilometers, 6 kilometers. And we're going to talk about a special case of geostrophic winds. Okay. Those are jet streams. Jet streams are special cases of geostrophic winds. Which means automatically jet streams will occur in high altitudes. Okay, what special case? Before we talk about the special case, let me tell you a very simple story. What story? Rabbit and tortoise. Oh. World War II. See, even though there are very, very bad things which has occurred due to World War I and World War II, if you look at development of science and technology, it is actually credited to World War I and II. You take space technology. Today, we are very successful as a human race only because Soviet Russia and United States of America tried to improve their success in space. In 1941, United States of America decides to join the war. Why? Because Japan attacked Pearl Harbor. Pearl Harbor was a very important naval station of the United States. A very big mistake by the Japanese. They will lose the war anyway. Now, after USA and Japan start to compete in the war, the entire world participates and there are two different theaters of war. One theater of war is in Western Europe and the second theater is actually in the Pacific Ocean. In Western Europe, you have Hitler fighting tooth and nail with several powers. He's fighting against Stalin on its eastern side. He's fighting against Britain. He's fighting against France also. But Pacific theater was kept wide open and these two countries on both sides were fighting tooth and nail. You had Japan and you had United States. Okay. At the start, they did not launch complete attacks. Complete attacks meaning it was very difficult for aircraft carriers to start from here. Sorry, not aircrafts, fighter jets. They start from United States, go to Japan, and then return back again. So initially, what they did is they might start in USA. They'll attack Japan. After attacking Japan, they'll try to move to Soviet Russia. Why the Russians? Because USA and Russians were actually on the same side of the war back then because they wanted to defeat Hitler. After some time, certain attacks were started from USA. They went towards Japan. At the same time, after finishing the attack, rarely you might find jets returning back to. Listen what happens. This was documented evidence. During many of the instances, fighter jets from United States reported that when they moved from United States to attack Japan, they were not able to reach on time and they felt that there was high resistance in the atmosphere for movement. So when they moved from USA to Japan, they moved very slowly. But at the same time, when they returned back, they were aided by a wonderful tailwind. They reached very fast. We're talking about significant changes of minutes. We're talking about 20 to 25 minutes. Minutes, you might think, no. Minutes are very important. In a war, if the enemy knows that you're going to be right there, 20 minutes he knows he can prepare his entire battlefield. So it makes a big difference. So let's say 4 years pass and only then they bring this problem to the meteorological department and the US weather system and the meteorological department begin to analyze. And they say, well, we have an upper atmospheric circulation which aided our fighter jets. Okay. And tell you something, this upper atmospheric circulation, which we are drawing in pink color, starting from western side to eastern side, was used by Japanese also. Japanese also understood there was upper atmosphere. You know what they did? They started designing bomb balloons. So they just tie bombers and they just launch balloons. Okay. They were expecting the balloons to travel from Japan, cross the Pacific Ocean and fall in the United States. 99.5% of the balloons did not reach. but two balloons actually reached USA. One reached Alaska and one reached the mainland United States of America. Luckily, no one was killed, but that leads to the innovation of Japanese. Wind is there, no? Just type, put, okay, no one died. Now let's try to understand what exactly is this pink color line moving between very, very fast, okay, high up. That's why I'm telling you fighter jets and balloons, okay. Jet stream is a geostrophic wind that I've established. Okay, I've told you it's a special case. What's special? If a geostrophic wind satisfies 4 conditions, you call it as a jet stream. Ready? So what are the 4 conditions? If a geostrophic wind is long, how long? We are talking about hundreds to thousands of kilometers. Actually, 2 global jet streams encircle the entire Earth. Okay, thousands of kilometers, are at least hundreds to thousands of kilometers in length. Extensive area. Number 2, fast flowing. How fast? You're talking about velocities of 200 to 250 kilometers per hour. Okay, very, very fast. You get it? Number 3, narrow. The words long and narrow go hand in hand. Okay, it's only about an idea of perspective. Okay, narrow is like if the length is hundreds of kilometers, the length is thousands of kilometers, then your width component is going to be very, very less, possibly tens of kilometers. Okay, so if you're going to have 1,000-kilometer length, then maybe 10 kilometers or 15 kilometers width. Okay, that is the ratio which you're talking about. Very, very narrow. Meaning makes sense. So long and narrow they are. It's a concept of proportionality or a constant ratio. Okay, if it's thousands of kilometers or hundreds of kilometers, the width will be tens of kilometers. Very, very small. And last one, meandering. Okay. Meandering is movement in a sine wave pattern, if you want the idea, like this, not moving in straight lines. If any geostrophic wind satisfy all these conditions, it is qualified as a jet stream. Jet stream. Okay. Finished now. Let me explain where they are found, basic idea classification and where they are found, why they are found in those 2 locations. Then we'll go to air masses. Is it clear? Fine. We will see a short video of them. Please wait. They are broadly divided jet streams. Jet streams are broadly divided as global and local jet streams. Global and local jet streams. Our purpose will be this one because I'm dealing with world geography. Local jet streams you'll see in Indian geography. Global jet streams, as the word clearly states, you're talking about 2 conditions. First condition, it is, as the word states, global. Okay, they encircle the entire Earth. Encircle the entire Earth. Okay. The next one, second condition, they are present throughout the year. So 365 days, 24/7. Local jet streams is the opposite. Okay. They won't be encircling the entire Earth, very, very small region, and they'll be present only seasonally. That is local, just the opposite, but local jet streams you will learn over India. So under global jet streams, we have 4 global jet streams, 2 in the northern hemisphere, 2 in the southern hemisphere. Certain textbooks will say there is only 1 jet stream and the jet stream will divide into a subtropical jet stream and a subpolar jet stream. But we just keep the discussion which is required from the exam perspective. We consider 2. Okay, that's much more a better way of learning and understanding. Is it okay? So where are my 2 global jet streams? Let me draw the northern hemisphere again. Let me draw the pressure belts all over. Equatorial low pressure belts, subtropical high pressure belts, subpolar low pressure belts, polar high pressure belt. You have this diagram with you. You've done it so many times. idea is this. There are two jet streams present exactly over subtropical high pressure belts and subpolar low pressure belts, and they move from western side to eastern side. Western side to eastern side. Both these cases. Please note they are not present at the ground level. That is what you need to understand. Listen for a second. Let me clarify the ground level point. We'll compare a trade winds westerlies and polar easterlies. Let's say this is your Earth. Trade winds will be like this. Okay. Westerlies, polar easterlies, very touching the ground surface and flowing if this is the Earth. You take jet streams. Jet streams are not surface winds, geostrophic winds, 4 to 5 kilometers, at times 8 kilometers, 9 kilometers above the surface, and they encircle the Earth in this direction. Meaning makes sense. Trade winds or westerlies or polar easterlies primarily move across north and south, even if they are west and east, but primarily they are north-south winds. You take jet streams are east-west winds, and they're not touching the bottle. You get the idea? So presence over at high altitudes, over subtropical high, tropical high, and subpolar low. Subtropical high and subpolar low. Okay, so this is my subtropical jet stream. Subtropical jet. And this is my polar jet. So clear. Polar jet. We'll see a video now so that it sets things in mind. Very small one, 30 seconds. Ready? Let's see the short video. So the visual is clearly entrenched in your mind. I think then we can proceed to air masses. Jet stream is still not complete. The actual reason why we discuss jet streams will be, fairly reasonable once I can go to the extratropical cyclones part. Yeah, this one. It is not just a issue. Before that, you'll ask me what is jet stream. Focus on this red color band of wind which is moving, okay? The red color is to indicate high speed. When winds are of low speed, you'll get that yellowish, bluish color. Red is your high speed, just look at it. See Alaska. See that? Stream. That is the reason it was much easier for you to come from Japan to United States to attack USA. Is it okay? That was the idea in World War II. There is South Coast. Parents are living there. That is not air. Okay. That is the idea behind jet streams. Does this jet stream happen in southern hemisphere also? Same question was asked here. See, please understand, all the phenomenon we see in the northern hemisphere, you have it in southern hemisphere also. Only reason I'm not teaching you southern hemisphere is we don't live there. Human beings, of course, humans live. The population is very less. Only 15% of world population is there in the southern hemisphere. It's largely made of oceans. That is why. See, if I'm a teacher from Australia, I will teach you southern hemisphere. Okay, the entire discussion of geography will be different. But I'm in northern hemisphere and that is what I'm concerned about. Fine. Okay, is it a polar or subpolar jet stream? Fine, if you want to avoid confusion, because later I might teach you one more thing, you better use the word subpolar jet stream itself. In case you want to avoid confusion, because you won't forget. Subpolar jet, subpolar low pressure belts. Later you will ask me, you used a different terminology. Is the direction same in southern hemisphere too? Yes. All of them, it is from western side to eastern side. The direction is from western side to eastern side, all the 4 of them. Okay. It can't flow eastern side to western side. No, you have only for local jet streams, global jet streams, western side to eastern side. Okay. Fine. That was the last question. So shall we move ahead? We need to look at air masses right now. Once air masses foundation is done, we'll have a 5 minutes break and then still the screen is being shared. Oh, just hold on. Screen share airka? Screen share airka? Illala? Oh, okay. Fine. So shall we move to air masses? You might be thinking, see, why jet streams? Just like physics we learned, no, it will be useful later. Please wait. Why high altitudes over subtropical high and subpolar low? Saravanan, I will take that question, both the questions. If you have any question on why it is occurring in these 2 areas, I will take the question later. Okay. If I take it up now, we'll not be in a position to. In the southern hemisphere, the Coriolanus force is left. Yes, Raj, it is left side, but still it will be in the western side, eastern side. Is it okay? If you want the answer why only in these 2 pressure belts, I will answer it at the end of the class. If I discuss now, it will be more, useful in terms of physics, but that will deviate from the requirement of the class. It's not required for exam, that is why. Raj, reserve your questions. Okay, all those questions, I will definitely deal with audio, and I want to know where your doubts are coming, including your cyclones part. Okay. Just don't post questions 1 and 2. Is it clear? I will take your doubts, man. Please be patient. This text is not really working out, doesn't it? That's why I ask you to wait. Air masses. Let me write the definition, then I'll explain. Large body of air. Body of air with the similar temperature, pressure, and specific humidity characteristics. Specific humidity characteristics. Extending over. Yeah, thousands of kilometers. In length and width. Length and breadth, that's a better one. Length and breadth. Done? Please note, air masses are not air parcels. Air parcels was a theoretical concept, and we used it only for determining our weather patterns and our weather meters. Air mass is something which exists in real life. But if you read the definition, it might look impossible. Look at this one, a large body of air. Okay, thousands of kilometers. Now, I'm telling you that you travel thousands of kilometers in air, the temperature character, pressure character, or your specific humidity character is not going to change. Now, this might seem odd. Why this might seem odd? Because you are in Chennai. You go to Bangalore, not far away. Okay, 500 kilometers. Fine. You go to Bangalore, even less than 500 kilometers. You think, go to Bangalore. You measure the temperature in Bangalore. You measure the pressure in Bangalore. You measure the humidity in Bangalore. Bangalore, everything will be different, no? Compared to Chennai. It will be different. Okay. So even for a very short distance, the temperature, pressure, and humidity characteristics are changing. So if you look at the definition, it might seem not okay. You might think that this cannot happen in several parts of the earth. But actually, what I've written is true. Only thing is, it may not be applicable to places like Chennai and Bangalore. Let me give you the conditions first of all, then let me show you the locations on the world where you find air masses. So number 2 is conditions for formation. And from conditions, we'll go to real places. First condition is this: homogeneity. Homogeneity. You take two different surfaces. In one surface, you do not find change in relief, highly undulating terrain. In one surface, there is high change, starting from mountainous systems to forest systems to lakes, rivers, and then maybe an urban system. In these two locations, location 2 is not good for formation of air masses. It is heterogeneous. Why it is not good? Simply because each and every surface will have a different specific heat. They will have different albedo. Right? If all those different surfaces have different characteristics, then naturally what happens is surface temperature influences air temperature. So if your surface is different, then naturally your atmosphere characteristics will change. A mountain will influence atmosphere differently. A forest area will influence it differently. Same can be said for your urban systems also. Meaning makes sense. But on the other hand, if you are actually in a region where the surface is homogeneous, let's say the surface which you're considering is flat, you don't have any features. Now, assuming that it is made of the same material, you are not going to experience, or you are going to create similarity in temperature, similarity in pressure, and similarity in specific humidity characteristics. Meaning makes sense. Fine. That is the reason homogeneity is an important condition. Is it okay? Your knee doesn't good look, man. Your knee is on the table, man. It doesn't look very appealing. That is the problem. You either switch on the video if you're not looking, if you're not really not good. People, I've told you several times, please switch on the video if you're not in a very good posture or not in a very good attire. Look at me. See, that's the problem. You can be informal. I don't care. You can be even in the bathroom. I don't care. Please don't switch on your video even accidentally if you feel that you're not professional or formal. I got to see that. Really. Still screen is visible. Just hold on. Just tell me now it's okay or not. Just tell me that. I don't want to have these technical things, Yes, no. Shall I proceed? Now it's okay, huh? Rishi, is it okay? Please stop sharing the screen. I am not doing anything, man. It's still not clear, but you can proceed. Because, everyone says it's fine. Please, we can, but it's there, but it's not disturbing. Oh, man. Wish we can really... He or she needs to switch from shared content. Okay, maybe it's because if at least I have the control of the system, I can ask you what manipulation is to be done, and I'm not controlling anything too, and the person says it's okay. Possibly from your system, please check the features. Is it fine? Okay, let me. It just disturbs really the flow of the class. Don't want that. Okay. So our discussion, okay, when the knee was put on the table was simple. You have a flat area, then you're going to have homogeneity. This entire area extending for thousands of kilometers will have similarity in characteristic. Okay. Number two. So same temperature is there. So mean similarity in surface is there. Same specific heat, same albedo. Yeah. It's there. Okay. So if the surface is going to be same, then naturally there is not going to be an issue because surface temperature is uniform. Naturally, air temperature characteristics, air humidity characteristics will be uniform. Now proceeding further, second one. Second condition is divergence at surface level. Divergence at the surface level. Is it clear? Divergence at the surface level. See, when we say divergence at the surface level, we are talking about air spreading over a large area. Okay, there are two possibilities. Either you can have divergence at the surface level. This is divergence. Or you can have convergence at the surface level. Convergence is not ideal for air mass formation. You get the reason. Why convergence is not ideal? When wind systems converge in a location, they will vertically move up. Once they vertically move up, they will lose contact with the ground surface. If you cannot have contact, you cannot acquire similar characteristics. Meaning makes sense. So these are not good. Come to a reverse condition where air is settling down. Once air settles down, it spreads over a very, very large area. Spreads over a very, very large area. So it spreads over a large area, it will begin to acquire the characteristics. So technically, these are high pressure zones, regions of high pressure where air settles down. There you'll get very good air masses. It might seem very odd, but if you look at the locations on the world, you will easily get a connection. Trying to visualize. Confused about what? No, air mass is a large area of air. That's why it will be in ground only. No, the air mass can be of a certain height. See, thousands of kilometers in length. The question is this: what about height? Okay, that's the question. Air masses are thousands of kilometers in length and width. The height can be few tens of kilometers. See, total tropopause height itself 8 kilometers and pole 18 kilometers. So height will be 4 kilometers, 5 kilometers. Okay, so that's the it's like, see, think about this cuboid box. The Tiffin box is there now, like that. Okay, that's how an air mass looks. So let me show you a picture, people. Yeah, the same flowing example which I did. Okay. See, once you see the picture, it will be consistently clear. The problem is, until you get that example part, you may not be in a position to visualize. That's the only problem with the subject. Okay, so let's go to world physical map. Nowhere else. And naturally find the connection. You yourself will tell me so many places on Earth are there. Okay, and how they're ideal for air masses. Yeah. First, let's talk about homogeneous surfaces. See, few regions of the world which produce consistent air masses and which they can affect climate is one right here. You take Sahara Desert. Sahara is a flat plain. You don't have any mountains. Only mountains. This Atlas Mountains will be on top. You leave out Atlas Mountains, entire region is flat. Okay, extension flat land. You take a region of Siberia, the eastern part of Russia. Okay, again, it's a plateau region. The entire region is flat. You don't find undulations. You find mountains only on the eastern coast and areas which are bordering Mongolia. But plateau is just flat region. Let's take Greenland, this one. Okay, you don't find mountains over Greenland. Greenland is covered with ice caps, I know, and glaciers. Fine. It's not just over land. Take Gulf of Mexico, this small water body here. It's completely surrounded by land. Is it not? You take a northern Atlantic Ocean. You take northern Pacific Ocean. Okay, you take your tropical Pacific, you take tropical Atlantic, these segments. All these regions, you will form air masses. All these areas, see, water where mountains are there, plateaus are there, water is just flat surface. So you take all these regions I've marked, it's extensive for hundreds and thousands of kilometers. This is where you find air masses. Major regions of the world. Okay. Yeah, deserts, very good. Now to talk about classification system. See, classification is way too simple. There is no complication at all. Let me just give you the names first, then we'll try to name them. Why do we name air masses? Just to differentiate. Okay. So let me name and come. So Sahara Deserts, North Atlantic, North Pacific, Tropical Atlantic, Tropical Pacific, Gulf of Mexico, same here, Tropical Pacific and Siberian Plateau. These are major regions of the world. Now let me take you to different types. I'll come back to the map again, then we'll try to see what types are there. See, you can simply classify them as continental and polar. Continental and polar, sorry, maritime, continental and maritime, based on the surface. Okay, whether it is formed on land or whether it is formed on water. You can classify them based on latitude as tropical or polar. Okay, whether it's present close to your tropical region or between the tropics, or close to tropics, or it is close to the polar region. These two are simple. Any doubts here? Closer to Tropic of Cancer or Capricorn, closer to your 90-degree north and south. Shall we name? Go by the physical map. Just let me know. Fine. So let me go there. So if you have to name the air masses, how will you do? Very simple. You take Sahara region. Sahara, it is land mass. So this is sea. Okay, continent. Now, is it in the tropical region or polar region? Definitely tropical region, right? So you just call it CT. Example. Let's come to Gulf of Mexico right here. This is maritime, right? M. This is over water. Use M. Is it tropical or polar again? This is T. Tropical. So MT. This one. This is also MT. Tropical. Tropical. Only thing is it happens over water. MT. This is CT. Now once you go north, well, it is continent, but this time it is not going to be tropical. It will be polar. It's closer to the polar region. So you call it CP. You come here right now. It is again continent over Greenland. Polar. You come to region of Canada. Continent. Polar. Once you move north, it is polar. But right now it is maritime, North Atlantic Ocean. You come to North Pacific Ocean, maritime, polar. Meaning makes sense. So naming them is very, very simple. So CT, continent tropical, maritime tropical, maritime tropical, maritime tropical. So naming them is simple, just a simple combination of words. Will there be air masses over every ocean? Yes, except North Indian Ocean. You can form them in South Indian Ocean, that is possible. North Indian Ocean is not possible. Why? India is there. As long as India is there, no possibility of air mass. There is no North Indian Ocean. India has covered North Indian Ocean. So except that, you'll find it in every ocean. There is in South Pacific, there is in South Atlantic, there is in South Indian also. I am South Indian. But not South Indian Ocean. Okay. You again ask me, anyone, again, any phenomenon. Sir, will it happen in Southern Hemisphere? Na? I will take you, I will book a flight. I will send you to Madagascar. I will definitely do that. You want to learn geography, learn from there. Then you will teach you. Every phenomenon will be, you are from Madagascar. Huh? No, I'm ready for you. Already? Huh? I will book flight, man. I will send you there. I'll send you to Madagascar. Okay. Tropical means low pressure. Then how ideal for air masses? Akhilesh. Look at this man. Subtropical high pressure belts. Subtropical high pressure belt. Sahara, desert condition, high pressure belts. Gulf of Mexico, subtropical high pressure. Look at the Tropic of Cancer is flowing. Do you understand now? Did I ever mark equatorial low pressure belt? See that. Divergence at surface level. Is it okay now? Tropical means low. Atta, you know why I get ticked off? Question layer. Tropical means low pressure. Did I tell you tropical means low pressure? Tropics means heat. Where do you find low pressure? Subtropical high na entire region is subtropical higher only. There only you'll get the area. You look at all these air masses, they won't be there in subpolar low. All of them will be go to polar high pressure belts. Why polar high pressure belt? Polar high pressure belt only, or that is where air is settled down. Air is settling down. This entire region. This is my tropical low pressure belt region. Here you won't find air masses. This may subpolar low pressure belt region. Here you don't find air masses. Now meaning makes sense. You'll get it only in the high pressure regions. Akhilesh, is it okay now? Is the diagram clear? You can't form in low pressure belts. Akhilesh, is it fine? Yeah, at least the question was useful. Now you finished the entire diagram. Huh? People. 2 more points, then I'll give you a break. We'll finish air masses, then we'll look at cyclones. I think you've taken. So no air mass in equatorial low, no air mass in subpolar low also. Present in subtropical high, present in polar high. Why? Because condition is this one, high pressure belt. See, apart from saying a continental air mass or a polar air mass, I can classify air masses based on temperature also. Air mass can be warm. Air mass can be cold. Right? An air mass which comes from Sahara Desert will definitely be hot. Air mass coming from polar region, Siberia, will definitely be cold. Is it okay? So air masses can also be classified based on temperature. So the temperature is based on surface. Okay, if the air mass temperature is greater than surface, temperature of air mass greater than surface, you call it as warm air mass. Okay, temperature of air mass is less than temperature of surface, that's full air mass. Okay. It's not over. Let me finish. Just written that. You might get further out. That's why I haven't completed. Just note this down. Temperature of air mass is greater than the surface, you call them warm. Temperature of air mass is less than surface, you call them cold. Immediately you'll ask me a question. Well, you told us that air masses will need the surface. In those instances, air mass temperature and surface temperature should be same. Then how is the temperature different? Well, I'm not talking about the surface. Listen, I'm not talking, this surface which I've written here is not the surface in which the air mass forms. Let me write this paragraph, note this down. Shall I take it now? See, the surface which came from the previous picture is this. After formation, air masses do not remain in the same place, as pressure belts shift, full stop. During movement, air masses affect the weather of the destination and at the same time the air masses get modified. Okay. So this statement will need to be explained. I will explain this and give you the break immediately. Copied? Copied, no? Yeah. See, it's like this. Formation of air mass will take some time because air will need to settle over the area. Maybe it takes a month, 40 days, 45 days for the air mass to form. Think about this. Winter season in the northern hemisphere is for 3 months. So if you take glacier formation over entire Greenland, the entire Greenland is already covered, and the surrounding your Atlantic Ocean also, let's say it's getting covered by ice. So first ice formation should be there. After ice formation, properly the high pressure belt is going to expand. High pressure belt expands, air settles over. 30 days, 45 days, air mass is formed. Now after formation, the season is not going to be constant. There is always a shift between the 4 different seasons. So naturally pressure belts will shift. Okay, we've seen pressure belt shifting when we saw Mediterranean climate. Now, when pressure belts shift, the air masses which you saw with reference to your Sahara deserts or the air mass which you saw with Siberian plateau, they're not going to be in the same position. Let me give you simple examples. You take the Siberian air mass during the pressure belt shifting, it can migrate right here. You take the Gulf of Mexico air mass, it can migrate north. You take the Canada air mass, okay, it can migrate south again. So these air masses will migrate from their source region. Now it is like this, listen carefully. Let's talk about this simple Siberian air mass. I come from a region, okay, where the surface is having very low temperature for a long time. So when this air mass begins to migrate, let's take it is coming to attack Japan. Japan is right here. Northern part of China is right here. So when Siberian air mass comes in, for 10 to 15 days, there is a sudden drop in temperature in Japan. There is a sudden drop in temperature in China also because cold wave will completely invade this region. Same thing happens for this one too. From northern portion of Canada, let's say Alaska and northern Canada is completely surrounded by ice during winter season. From this, when they move down here, okay, the entire Canada-USA border and the eastern coast of USA will experience sudden drop in temperature. It will stay there at least for 1 to 2 weeks. So the destination gets affected. That's what you've written right here. You know, look at this one. The same place in pressure belt shift. During movements, air masses affect the weather of the destination. Okay. Can be northern China, can be Japan, can be your eastern USA also. And at the so when air mass was migrating, it suddenly stopped. Why it stopped? God stopped. Come back here. See, the last point, once I move away from destination, I'm not still in contact with Siberia. I'm not still in contact with Siberia, still in not contact with Greenland. Naturally, I cannot possess the same character. My character will also change. That is what I've written here. At the same time, the air mass gets modified. Now the statement is clear. Contradiction with which statement? When the air mass gets modified, air mass will dissipate. That's all. You get the meaning. You need that for air mass formation. Formation. After it is formed, once the air mass has started to move, then the air mass will die out. That's all. Meaning makes sense. People understand the question was in the previous case, you talked about homogeneity. Okay, but now the condition is getting modified. You don't have this condition of, where is it? Yeah, a similar temperature, pressure, and characteristics. Why do we call it air mass? That's what I'm concluding. You need this condition for formation of air mass. After air mass is formed, once the air mass migrates from its source region, it reaches the destination, the air mass will get modified. Once it gets modified, it will finally die out. Okay, air mass will occur, it will form, then it will move to an area, then it will disappear. Is it okay? So one case of disappearance or one case of modification only is extratropical or temperate cyclonic systems. So before we go with that, take a break for 5 minutes. Okay, then we'll proceed. Any doubts are there? Reserve it. I'll take it at the end. 5 minutes. Sri Lakshmi, in the last class for us, it was the climatic region that we are discussing about, and we completed Mediterranean climatic region. You'll be completing that. Sri Lakshmi, please raise your hand. Didn't we complete Mediterranean climate already? Slide number 9, geostrophic wind. I think we saw that. Show the slide. This is it, right? Please raise your hand, Sri Lakshmi. The person not there. Sia in 2041625. Just want clarity. Any B3 student is there? Please raise your hand. Please, hand raise. Yeah, B3. Hello? Hello? Audio is there? Madam, is it audible?
Yes, sir.
Ma'am, just tell me, like, see, hold on. Jetstreams is completed for your batch, right?
Yes, sir. We completed the last class with jet streams.
We finished tropical cyclones for you, right?
Yes, sir.
Okay, so we finished British climate?
Yes, sir.
You finished Mediterranean climate?
Yes, sir.
Then why confusion with your batch? Because one person has sent a message that Mediterranean climate is not complete. Did I end with wine manufacturing? Yes.
Yeah, we've included that as well.
Okay, then
The economic development in Mediterranean climate.
Exactly. Then
That's what we've discussed the last year.
Yeah, so
we're done with that, sir.
Fine. Thank you. Thanks. You know, I got confused. Now, I was pretty confident that it was done. People, now we are going to look at a different type of cyclone. And let me tell you now itself. Let me finish. Until I finish temperate cyclones, until I compare tropical and temperate cyclones, you will feel dizzy. Let me finish. Patience is very important. Don't interrupt me for the next 40 minutes. Reserve your questions. That's why I told you. Start the vehicle after stopping only. Ask question. Shall we start? New type of cyclone. This cyclone we can't see. This cyclone comes in Spain, United Kingdom, North America and all. This USA Canada border. Russia, Germany, there it might come. Here it won't come. Just give me ready, if you're ready. Okay. So what different type of cyclone? Second type, extratropical or temperate. Both names you can use. Temperate cyclones. The cyclones form in the latitudes of 45, 65 degrees north-south. Okay, number point 2. They occur mostly along the subpolar low pressure belt. That is why 45 to 65. Subpolar low. 65 you will agree. You might ask me, sir, but subpolar low pressure belt is found at 60. How come 45? Pressure belt shifting. Okay, pressure belt, let's say pressure belt shifts south. At times, you know, certain small portion of the pressure belt can come south also. Okay. So back then, the condition of formation we saw with reference to your tropical cyclonic system was that the shallow water body should be very, very warm, and you should have this vertical upliftment. Then there is formation of your clouds, and then there should be more divergence at the top level. Extratropical cyclone, the reason for formation is much more simple, and the reason it stems from temperature difference. To appreciate temperature difference, let's just start this. Okay. Let's take northern hemisphere again and let me go to the place of interest. Equatorial low, subtropical high, subpolar low, polar high. Now, in this region of interest, subpolar low, let me draw two wind systems which you're familiar with. One is my westerlies coming from 30 degrees. One is my polar easterlies. They come from the north, 90 degrees. Okay, and they meet in the subpolar low. There is an inherent temperature difference between westerlies and polar easterlies colliding. Okay. Westerlies come from subtropical high pressure belts. That is, after descending over hot subtropical deserts of the world, they start their ascent towards your north. At the same time, you take your polar easterlies, after descending over glaciers and very, very cold waters and land masses of the northern hemisphere, they move down south. You get the meaning? So, which means these two regions, the westerlies temperature and polar easterly can't be same. I come from 30. So, naturally, if the air masses are, being moved by the westerlies, this will be much, much warmer. Yeah, westerlies are warmer. I come from a cold region, so naturally the temperature will be less cold. The reason for formation of extratropical cyclones is because there is temperature difference between air masses. Reason for formation, presence of temperature difference between colliding air masses. We will need to conceptually visualize this. Please wait. Colliding air masses. Visualization is the idea. Okay, then I'll take you one by one. People understand what do we mean by temperature difference and why does it take a long time and how does cyclone form? Let me take a glass. Now in this glass, if I fill half glass hot water, half glass cold water, how long does it take for the water to mix properly? Even temperature, hot water, cold water. Few seconds. Few seconds, the temperature should normalize. It should reach average temperature. Let me keep this glass away. Mixing now, hot and cold water mixing. Think about a bathtub. I will keep a cardboard in the center. So one side is fully hot water, one side is fully cold water. I will take this cardboard outside. So now hot water is going to mix with cold water. Now again, this mixing process will come together and they will reach a normal temperature. Problem is, this mixing is going to take a longer period of time compared to this glass. Why? Because I increase my volume, right? Once you increase the volume, temperature is increasing. The time period is increasing. You have any problem, think about the room which you are in right now. Visualize again. Okay, let's say you're trapped inside the room. Half room is hot water. This entire room, half room hot water. Half room cold water. Then you remove the barrier. Now again, you give enough time, hot water and cold water are going to mix easily. Mix again. But they will mix easily, but time period is a problem. What happened in a matter of seconds in a glass? What happened in a matter of 1 or 2 minutes in a bathtub or 3 minutes in a bathtub might take hours if it is an auditorium. Correct? Now, look at the definition of air mass. What is the size of air mass? Hundreds and thousands of kilometers. So for hundreds and thousands of kilometers, if the air mass is warm, hundreds and thousands of kilometers, air mass is cold, when two different air masses come and collide against each other, then it is very difficult for them to mix. Okay. If they want to mix also, it will take a very, very long time. That is what we mean as presence of temperature difference. If the temperature difference is very, very long, it's not a glass or a bathtub or a room. Due to high difference in temperature, collision temperature variation is there. So due to this temperature variation, one air mass will fight against another air mass. And during this fight, a circulation is initiated. That is how you form temperate cyclones. Meaning makes sense. So high temperature difference. Due to high temperature difference, the air masses cannot mix easily. Since they cannot mix easily, a circulation is initiated. Fine. So let me put it down. The colliding air masses colliding air masses cannot merge due to different characteristics and their enormous size. Okay, this initiates cyclonic circulation. Is it clear? That is the reason why they start to circulate. Now, how they circulate, what are the weather systems you need to change? Finished. I'm going to introduce two definitions again. Very simple definitions. Front. In climatical terms, it means front. A boundary between air mass and its surroundings. That's all. Front, boundary between air mass and its surroundings. So I drew the cuboid, isn't it? Okay, the separating point between the air mass and the surrounding environment is called as front. Now, from this, a derived definition. The derived definition is frontogenesis. Okay, simple thing. Frontogenesis. See, frontogenesis. Genesis means creation. So, frontogenesis is creation of fronts. So, colliding air masses results in frontogenesis, which can evolve into cyclonic systems. Okay. So creating that boundary difference between an air mass and its surroundings is frontogenesis. When you get the proper boundary, when warm and cold air masses are colliding, and this frontogenesis can become a cyclone. Just like we saw a depression becoming a cyclone. Frontogenesis is the name of the process. Now we're going to look at two terminologies, warm front and cold front. If you want to understand warm front and cold front and the climatic appreciation, we will need to go to World War II also. Okay. So first, why did the name frontogenesis, or how did the name frontogenesis comes in? I'll go to not World War II, World War I. And then from there, I'll come to your climatic system. World history started, world history over, anything for your batch? World history. World history has not started. Right. See, the theory of frontogenesis and formation of temperate cyclones was developed by two Norwegian meteorologists, father and son duo, Jerkins. Okay, Jerkins, it's a Swedish Norwegian name. I don't know how to pronounce that word. And they developed the theory in 1919. 1919 was the end of World War I, and their theory is heavily inspired, not theories inspired, but the terminologies used in the theory is heavily inspired by what the events of World War I. In the World War I, a new terminology was used to denote the presence of two different types of military groups on either side. The term was front. One of the reasons why World War I extended for several years, it went on for 4.5 years. No one expected it to be. They expected the war to be over in 12 months or 18 months. The reason for this extended timeline is because for the first time, trench warfare for practice. Now, this is not really modern. If you look at historical times, this is very, very natural. What in trench warfare people do is this. They begin to dig in deep trenches. You can see that this is a full-grown man. Okay, and he's standing right now, and he will actually be standing on a podium. Okay, the depth of this could be as big as 15 feet or something. So, and you see a huge lineup of soldiers, right, lined up. So, if you're a German soldier and if you want to protect your positions, what you do is you dig very deep trenches and you assemble all your, you just order them, all the soldiers, and all of them are lined up. They're wearing their helmets. At the same time, they are fired up with their guns. Now, if you're an opposing soldier and you look at this formation, you can't do anything. You have guns lined up, right? So all you can do is wait. At the same time, if you want to protect your position, you can also, if you're on the French side of the war, you can also construct trenches. So what happened is, people held on to their positions. It was not possible for anyone to move in or move out. They simply stayed there because they were afraid, because you can't shoot anything. Already the person is having a gun, you see only the helmet. So if you look at your positions which were held up, like this is the Western Front. You see this line? No one made any progress on this line for more than 1 year, more than 1.5 years. Army was waiting on the other side. Okay. Why did they use the word front? See, you take one side of the front, the character will be different. French soldiers, French military, French tactics, totally different. On one side of the front, you have German soldiers, German tactics, and German strategy. It'll be totally different. So front is a clear division, and the character of the armed forces on either side of the front were totally different. Applying this to meteorology, you can say that whenever there is a front, the character of your atmosphere and weather pattern will be totally different on either side, just like French and German soldiers competing on either side of World War I. And one trivia, general trivia is this. If you've seen this film, Wonder Woman, there is a scene. Seen this film? Why, man? Such a beautiful film. Okay. Not just the heroine. The film is very good. Wonder Woman. Okay, if you have time, you watch. The second film is releasing. Fine. So in this film, there is this no man's land scene. Okay, where everyone warned her. So she's actually inside a trench where everyone warned her. No one has crossed this area for 2 years or 3 years, and she says, "Punch dialogue is coming. Okay, I am not a man. I am a woman. I will cross this area," and she crosses. No man's land scene. Fine. So let me tell you the meaning of the usage of front and extratropical cyclone. Listen here. Subpolar low pressure belts, warm westerlies, cold polar easterlies. Temperature difference is high. High temperature difference, frontogenesis starts. So frontogenesis has begun. Okay, so beginning of frontogenesis. Frontogenesis. World history started for a week. Okay, possibly B3 should have started there. Instead of spoken about. This frontogenesis section, whenever you look at the pressure belt, you know it's a low pressure belt. Let's say a cyclonic system is starting. Both the air masses are colliding. Okay, due to difference in temperature, one is trying to overcome the other. People understand. Please make your attention. Get your attention ready for the next 15 minutes. We can close in 15 minutes. I just need to have your attention. This is the top view. Top view means you're looking at this phenomenon, subpolar low pressure belt, from outside the Earth. Let's say you're Iron Man, you just fly out, or Superman, you just fly out of the Earth, several hundreds of kilometers. You just come out of the Earth and you're looking from the satellites. Is it okay? Anti-clockwise circulation, right? Anti-clockwise circulation. Now, what I'll do is I'll divide this into two parts. Okay. You take this anti-clockwise circulation in the right segment, or one part of the segment, which is on the eastern side. Here, warm front will be present. Warm front. In this case, warm air will invade cold air. Will invade cold air. Wait. Let me fully explain, then you'll understand. The second segment is your cold front. This one. Cold front. This part is my cold front. Cold air invades warm air. People wait, you copy and tell me. Use the word finished if you're ready, I'll explain. I know this is not enough, that's why. Please wait. Use the word finished if you're ready. Good. Wait. Listen here. I will return it without damage, don't worry, okay? I don't know magic and all. Notebook will be here only. Okay. This is pink color, close to red color. So this is warm air mass. This is black color. Black is not close to blue, but this is the book I have, so cold air mass. No, you use the notebook. Use. Okay. No, it's big, it's very heavy. I can't hold. I'm a very weak man. People, listen here. Listen. Red color, warm air mass. Where does it come from? Subtropical high pressure belts. Correct? So subtropical high pressure belt is here. From subtropical high pressure belt, warm westerlies are moving north. They're moving towards polar region. Correct? So from 30 degrees, they're moving north. That's the green color line I've drawn. This is cold air mass. Warm air mass is this, coming from subtropical high pressure belt. This is cold air mass. Cold air mass comes from North Pole, close to North Pole, right? So polar high pressure belt, right there. From the north, the cold air mass is coming. See what happens? Listen. Warm air mass, cold air mass, warm air mass, cold air mass, both of them are hitting each other. Hits. Temperature difference is very high, extending hundreds and thousands of kilometers, which means they cannot mix easily unless a glass tumbler. Now, once they have collided with each other, people listen. They have collided with each other in subpolar high, low pressure belt. This is what I told you, looking at top view, not front view. Either front view. No, this is top view. Anti-clockwise direction, subpolar low pressure belt, cyclonic system, anti-clockwise direction. Look at my rotation right now. People listen. Look at this one. Low pressure. Anti-clockwise, then. Anti-clockwise. Anti-clockwise. See. I have not done anything. Colliding. Anti-clockwise direction. Anti-clockwise direction. Fine. Good thing we have a notebook and a book. So you see the central line? That is a central orange color line I've drawn. You see that? Now let me explain warm fronts. When there is anti-clockwise direction, anti-clockwise, you see that this pink color notebook is actually going inside the black color book. Yeah. So warm air is invading into cold air. Can I say that? That is what we've written as warm front on one side. And there is anti-clockwise direction, this one. Okay. The red color, the pink color book is moving inside the cold air. So warm front, warm air invades cold air. That is called as your warm front, this section. Is it okay? You come to the other side. See, I'm not changing the rotation, people. Rotation is same. Anti-clockwise direction. Now, we don't focus on this side of the notebook. You focus on this side of the notebook. Here, see what happens? Yeah, who's coming in? The black color book is coming inside the notebook. This is the region where cold air is invading warm air. That is why on the other side you have cold front. See what happens? Warm air invades cold air. Warm front. Circulation continues, no? Cold air invades warm air. That is my cold front. This is frontogenesis. Now meaning is clear? Okay. If I can proceed, use the word proceed. That is how a warm and cold front gets created. The soldiers are ready for battle. Frontogenesis, creation of warm and cold front. Okay, people, fine. Now let's see after frontogenesis what exactly happens. First, usage of symbols. Okay, you can represent warm front and cold front just by using symbols. How means? Same diagram, nothing changed. Warm air, cold air, division. Let me use yellow color itself. Areas where warm air invade cold air, no, warm front. Warm front, they usually represent in weather systems using semicircles. Semicircle will be there. Okay. Cold air, they usually use triangles. Triangles. If you look at any weather map, no, where cyclone is getting formed or where frontogenesis started, they'll use a symbol. Where you find these, their warm front is there. So this is cold front. Cold front. Anti-clockwise direction. Now, what is the second segment we are going to understand after symbols? We are going to determine what is the weather pattern, where are you going to get high rainfall, where are you going to receive low rainfall in different parts. Now I'm going to draw diagrams of side view. Is it clear? We'll finish side view, then I'll complete it. So 5 minutes are done. We have 10 more minutes. Okay, before we can finish and revise. Comfortably done. Symbol is clear? Semicircle one. Cold piercing, so triangle. Kutting, kutting, you know. Kuttu means punch. Okay, it's a Tamil word. There is no English word kutting. Okay. Kutting you have in Hindi also. Piercing. Okay. Okay. See, now we are going to see what is the weather pattern. I will draw two diagrams, one for warm front and cold. Let me keep, yeah, I need one more page. 1, 2, yeah. Warm fronts, cold front. So we are going to understand, this is side view, people, not top view. Okay, like when the soldiers are invade, two soldiers are fighting. Warm is attacking cold, cold is attacking warm. So how will the wind systems move? How will cloud formation happen? That is what we are going to understand. See, when warm air invades cold air, this is surface. Let me draw the line also. This is surface level, and land. This is land. Warm air invades cold air. Warm invades cold. Cold invades warm. So what is the difference between both these areas? What weather pattern are you going to experience? Listen. Then you can copy, I'll give you time. Listen both these cases. I'll give you time. No problem. See, compared to cold air, you take warm air. Warm air is something which is, the kinetic energy of molecules is slightly higher. There is more temperature. So because of that, if you look at the packing of air molecules is not very tight. They're slightly loose. So when warm air moves horizontally, when warm air invades cold air, okay, it's moving inside cold air, this is what happens. Layer by layer. Soldier 1, Soldier 2, Soldier 3, Soldier 4. Soldier 4 will be flying inside, like Superman. You get the idea? This is how the soldiers are attacking in. Now, why are they moving like this? The reason being, the kinetic energy is slightly higher. So packing is very less. So the winds are kind of mixed up. So warm air moves into cold air. This is the direction, or this is the velocity of winds you get. Okay. There is less tight packing. So due to less tight packing, okay, the winds move like this. Is it clear? You have this very gentle slope. A very gentle slope. So this is my warm front. The pink color line. Pink color line is my warm front. This one. Got the idea? Draw warm front alone first. Since the packing of molecules is less, the kinetic energy is more, they just move freely. So a gentle sloping front you get. Side view, again, always remember, not top view, side view. Finished? Now, you take your cold front is different. Okay, the molecules, are the layers are tightly packed. I had settled down properly. So if you look at the soldiers moving, let's say German soldiers moving into French area, 1, 2, 3. The bottom portion will always be slower because he will experience friction. That is the reason. So the soldiers are moving like this. See what happens. Just remove these soldiers. Now, If you look at my cold front, this is how the cold front looks, right? That's my cold front. This is very, very steep. The warm front is gentle. Warm front is gentle. And this is very steep. See. You can ask her, what is the relevance of this? Why should we understand the side view? You should understand the side view for what type of clouds form and what weather systems occur. In these two regions, one area only, weather system will be very severe. You will get thunder, lightning and all that. You'll see what it is. Finish now. Huh? So let me compare this diagram. I will come back to this diagram. Wait, before that, a sample I need to give. Usually I give mountains. I'll give a simpler explanation. If this explanation is enough, you just take this. Let me not even go to mountains. Listen here. You are here. You are here. You need to climb to first floor. Steps. Steps. You tell me, people, condition 1, condition 2. You are climbing top. Between these cases, which case will you spend more energy? 1 or 2? Steps when you're climbing, which case more energy you need to spend? A step to this much now, you need to climb up like this. Either you're just walking slowly. You get the idea. Where you're going, yeah, step will be just like this. There is no attempt at all. In a steep slope, you need to jump. Okay, I'm like this. Get the idea. It will be in case number 2. You get the idea. So here, energy spent will be very, very high. Steep steps, some stupid civil engineer will be there, will construct like this. Seen some buildings like that? Did I talk about warm and cold? Now, why you went to warm and cold? I asked this question only, no? This you understood or not? So thanks for responses. Most responses were 2, which means you were right. You're going to spend more energy. It's not 1. Sleep steps. People listen here. Both these cases, only warm air will rise. Cold air cannot rise. How will cold air rise? Cold air has less energy. It doesn't heat up and rise. But how the air rises is different. The first case which you see right now, the warm front is this case. Gentle slope. Gentle slope, that much air, that much amount of air passes won't rise very rapidly. Slow amount of rise. So will you have cloud formation? Cloud formation will be there. But cloud formation will be slower. You will get clouds. But clouds will be like cirrus clouds you will get. Okay. Stratus clouds you will get. Is it clear? Cirrus clouds, stratus clouds. So this will give rainfall, but rainfall will be light rainfall. Light rain. Okay, why light rain? Because work done is less. Work done is less. Or slower. Slow and less. Okay, very slowly. So slowly one air pass will rise, cloud will form, some rain will be there. Some air passes, cloud will form, rain will be there. So you get light drizzling rain. Note it on the first case now. Slowly. Done. Second case, understand, cold air is not rising, something else is there. Here also warm air only, there is a difference. Second case is this one. You rise up after spending large amount of energy. Now here, cold air is coming in, isn't it? Warm air will be there. Cold air will be like, warm air showing off high kinetic energy. I will take you and push you up rapidly. Meaning makes sense. All the warm air which is present will be rapidly forced up. Cold air will sweep in from the bottom and warm air will be forced to rise up. So you look at the time duration, it doesn't have any time at all. Just like the steep steps, you get large scale cloud formation. Okay, you get cumulonimbus clouds here. Cumulonimbus clouds. So just like you move up a steep step. So cumulonimbus clouds, and here you get heavy rainfall, very, very heavy rain. Thunder and lightning. Okay, why? Because work done is rapid. work done is rapid. It's very fast. High. Okay. Just like climbing up a steep staircase. So where do you want to stand? Do you want to stand in warm front or cold front? If cyclone is coming, where do you want to stand? Where do you want to stand if cyclone is coming? Where do you want to stand? Just asking. You want light rain or cold? Heavy rainfall? Light rain is enough for you. Problem is, light rain alone won't be there. That is the problem. Use the word proceed if you're ready, people. Warm front, you want to stand. Problem is, alone, only warm front you will not experience. Sometimes cold front will come. We'll see how. Next is weather pattern. Use the word proceed if you're ready, if you copy this one. Fine then. Let me take you to my favorite country. My motherland, England. Why? Because those people colonized us for so long. I get very happy when I speak about England. London. Sappola low pressure belt. Warm air mass, cold air mass. There is frontogenesis. People listen, then I'll put it in words. Warm air mass, cold air mass are colliding. Visualize this. I am in London. Now, using my face as a reference, see, the reference point can be anywhere. Like, I keep myself as a reference, and I assume an anti-clockwise direction from this side. So, what will be the weather situation which you get? Okay, you need a starting point, that's why. So, I'm in London. Let's say this is my rotation, anti-clockwise rotation. So, first case, we're going to see what weather I will experience. In a tropical cyclone, it was way too simple. There is no rainfall in the eye, a very short diameter, and there was heavy rainfall completely in all parts of a cyclone. Temperate cyclone, four different weather systems will be there. At the start of the cyclonic system, if I look at the clouds, this is what I'll experience. See what happens. Anti-clockwise direction. Warm air is coming inside cold air, which means what front? Warm comes inside cold. What front? Warm comes inside cold. Warm front. So here, the red color notebook is going inside the black color book, which means there is warm front. I will experience light drizzling rain for 2 days. That time itself, I should be careful. Okay. So light drizzling rain is a proper indication. Second one, see what happens. I'll continue the rotation. Listen. My face, the warm front is crossing. Once the warm front is crossed, my face is completely inside warm air. Always remember, if you're inside the air mass, there will be no rainfall. Only in the frontal regions, air mass is getting uplifted. So once warm front, 2 days. After that 2 days, I will be inside warm air. Bright sunshine, good temperature. There is no problem. Okay. This will be there for 2 days. 4 days done. Fifth day, as a cyclonic rotation continues, see what happens. Problem comes. 1, warm front. 2, completely inside warm air. 3, who's coming in? Cold air is coming inside warm air. So this is the edge is my frontal portion. Now I have cold front, extremely heavy rainfall, thunder, lightning, cumulonimbus clouds. 5th day, 6th day. Now crossed. This will also cross after some time. After crossing, now I am completely inside cold air. Here there will again be no rainfall, but one difference with warm air mass is, warm air mass there was bright sunshine. When I'm inside, completely inside cold air, there is this drop in temperature, there is this high pressure condition. Okay, but again rainfall is absent. Why? Only in the frontal portion, only along the cold front or the warm front, air mass will rise up. So in an extratropical cyclonic system, there will be 4 weather systems. Okay, so with my reference point, it shows us London, the 4 weather systems in order are these. So 4 different weather conditions. This happens over a period of 7 to 10 days. It takes a long time for completing one cycle. Number 1 was warm front. In warm front, there was light rainfall. So first you will experience light rain. Number 2 is called warm sector. Warm sector means completely inside. Completely inside warm air mass. Completely inside warm air mass. You're inside the air mass, you have no rainfall. Number 3. After the warm air mass passed, the red color notebook passed, the black color notebook was invading into warm air. So cold front. So whenever there is cold fronts, there will be heavy rain. Heavy rainfall. And finally, there was cold air mass. Cold air mass or cold sector. You're completely inside cold air. Inside your cold air mass. So here, there is again no rainfall. So 4 instances, only 1 instance of high rain, 1 instance of light rain, 2 instances of no rainfall. So this is different from your tropical cyclonic system, where there was simple weather system. No rainfall in the center, heavy rainfall everywhere. But this is slightly different. This light and heavy rainfall take place in a cyclic manner. Yes. Yes, of course. So temperate cyclone, you will get both the good things and bad things. How to mention 4 different systems in a diagram? You cannot represent 4 different systems in a diagram. I will give you the sequence diagram in the next slide. I'll draw the sequence diagram which you can use in your exam. If you're ready, I'll proceed further. For the top view side view one by one. Ready? Use the word proceed. Because so far I did not tell you how the cyclone will stop now. We'll finish the diagram and see how the cyclone stops. Why there has to be an anti-clockwise direction? Answer is low pressure system, Raj. That's all. I don't want to say anything else. You are in a low pressure belt. What else do you want me to answer? No, here there is no eye. You don't have an eye. No. You don't have a circular eye. There will be an eye of the cyclone. We will see. Okay. It's not that you don't have technically a circular structure. There is no proper eye of the cyclone as such. Tropical cyclone you're asking. Tropical cyclone, there was an eye. Here you don't have anything. Raj, the answer is simple. Why there has to be an anti-clockwise direction? It was there in yesterday's class. Low pressure system, you get an anti-clockwise direction northern hemisphere. I've mentioned it so many times. This is subpolar low pressure belt. But again and again, you ask the same question regarding your jet stream western to eastern side also. Are we clear? That is a tropical cyclone, not equator. I'll deal with the question once we finish the sequence diagram. Okay. We'll finish the part. Close it out. See, when you draw this in the notebook, draw sequentially. Top 3 regions will be my top view. Top view, that is outside the satellite, how will things look like? This will be my side view. We'll see what happens. Frontogenesis, top view. Warm and cold air mass is invading. So warm front, let me use green color for that. Warm front, cold front. Top view. Okay. Surface. Video is clear. Video seems blurred. Oh. You were not in yesterday's class. What do I do, Raj? No worries. You might be working. I can understand. No worries at all. Please look at the video and come. No problem. Ready, Acha? Okay. Yeah, I think now it's fine, people. I was conscious that the video is blurred. That's why I stopped. This is my top view. Okay. I'll divide. So one side, what you have is warm frontal. See what I draw. For this exact warm front, I'll be drawing the same segment here. Okay, so warm air is invading cold air. warm air, sorry, this one. Warm air, see, is invading cold air. Warm invading cold. Warm front, C. Diagram is clear, no? Warm front, exactly below that I have drawn. Second one, cold fronts. Cold air should invade warm air. Cold air is there. Cold air is invading warm air. Steeply sloping cold front. Warm air. Nothing you have done. Same diagram. Warm front, warm invades cold. Cold fronts, cold invades warm. Okay. So as I told you, there is no I for a temperate cyclone. As the frontogenesis process continues, the distance between the warm front and cold front will slowly reduce. Now, why does the distance reduce? The distance reduces because the cold front slightly moves faster. Okay, so see what happens. Top view. Just listen for a second. Later you might get doubts. Top view. So as the rotation proceeds, rotation anti-clockwise direction, the distance between the warm front and cold front will reduce. So this is what I'm going to draw. Okay, so warm front and cold front, the distance slowly reduces. Okay, so this is my low pressure system properly created in the center. Okay, so if you try to represent the diagram, surface, no change in diagram except for one thing. The distance will reduce. See what happens. Warm front, warm air, invading cold air, warm air, cold air, invading warm air. Okay. So separated, fronts are closing in. Fronts are closing in. Now what happens at the end? What is the representation used for the final stage? Well, let's see how the cyclone stops. Once you've drawn, you tell me. Let me explain how the cyclone will stop. Or when this frontogenesis becomes frontolysis. Frontolysis means death of fronts. How many? Draw fast. You draw. Then I'll explain. I've never seen anyone 5-color pen, man. That's why. Red, black, blue, green, pink also. People listen. How does the cyclone end? The cyclonic rotation goes on. Okay. It goes on for a few days. 4, 5, 6, 7, 8 days. During the cyclonic process, something which is observable naturally happen. Between warm air mass and cold air mass, during this rotation, which has more energy, warm air or cold air? Warm air. Warm air has more energy. See what happens? Very slowly, this is not just warm air rising, entire warm air mass will uplift. So see what happens? Collision, rotation. Yeah, this will be much easier for me. Rotation. During rotation, entire warm air mass will rise and leave the system. Meaning makes sense. Entire warm air mass will be slowly uplifted. Rotation will go on. After 4, 5, 6, 7, 8 days, this will be the structure. So finally, you'll get something like this. Entire warm air will be on top. Entire cold air will be at the bottom. So if you let me put the side view diagram first, it'll be easy for you to visualize. Listen here. This diagram is there. I'll just club both of them together. Once I club both of them, see what happens. Both the fronts will merge, people. Both the fronts will merge. Okay. And at the bottom, you'll find only cold air. This W is there, no? Entire W will lift up. That's all. You get the idea? So how do we represent this in the top view? Well, this is called as occluded front. Occluded means cut off, shut off. Okay, and it is represented through this. Whenever occlusion happens, it means that warm and cold front is merged. Since both fronts are merged, they will represent a diagram like these. They'll combine both of them. So warm front and a cold front have merged together. Okay, and they're closing down. This is the final stage. Slowly the cyclone will dissipate. Why does the cyclone dissipate? Last point. Cyclone dissipates because during collision there is temperature difference between air masses. Naturally they will rotate. Temperature differences there can't overcome each other. After 7 or 8 days, warm air masses completely uplifted and cold air masses completely at the bottom. So in this type of condition, there is no temperature conflicts. This person leaves, 5 is enough, man. 7 days, I'm very tired, I'm tata, bye-bye, see you. Once the temperature difference is over, the cyclone will dissipate on its own. Okay, there is no more rotation. So the last stage is called occluded. Yeah, this is top view of the occluded front. This is the side view. Yeah, both have merged. See what both have merged. When both have merged, both the triangle and semicircle are represented together. You'll just close, just like closing a zip. That's all. Okay. So you have one final point before the break of 30 minutes. Occluded means shut off. That is, warm air is shut off from the ground. I will write that in the next page. If you've done, you tell me finished or not. Done? So last point, we'll end with this. What are the 4 forms of precipitation? Rainfall, snowfall, hailstones. One more is there. In the final stage, the warm air mass is completely uplifted, by the cold air mass. And is called as occlusion. In this stage, frontal temperature inversion occurs. Where sleet is possible or where sleet can occur, can precipitate. Last page, this was the diagram I gave you. You may not have noted it when you were drawing. So at the bottom there was cold air completely. At the top there was warm air. Correct? So in this occluded stage, very, very rare chance which happens only in this occluded front, with increase in altitude, you're moving from cold air to warm air. So there is temperature increase. Since it happens as part of frontogenesis, we call it frontal temperature inversion. If you want to understand the meaning of this, go back to your notes, look at forms of precipitation, answer will be there. In your notes under forms of precipitation, refer sleet, you will understand. Okay. Very good. See, cold front has less velocity. Understand? Again, it's not cold front having less velocity. Please note, it's more about dispersal. Okay, when I say that cold front is moving faster, I'm not saying that cold air mass is having more kinetic energy. That is not the understanding. It's about moving in a single direction. See, there is a problem if the kinetic energy is slightly higher. Problem with warm air mass and warm air front is visualize this in 3 dimension. Okay, if the kinetic energy is more, air tends to disperse in multiple directions. Okay, so unilateral singular movement is not possible. Cold air mass, on the other hand, that level of dispersal is not there because kinetic energy is going to be less. So since the layers are packed, when the rotation is initiated, they will uniformly move in one direction. Warm air mass, you cannot expect that because the kinetic energy operates negatively in this case. You want to move in multiple directions, that reduces your velocity. But cold air mass, even though kinetic energy is less, it moves in a same direction. Okay, that's why it is. Yeah. CIN 2006366. Priya, thank you. Rainfall, snowfall, sleet, hailstones. Correct. That's the reason why cold front sweeps through. So that ends the discussion for your temperate cyclones and extratropical cyclones. So if you have missed any slide, please don't worry. I will show the slides, no issues at all. Okay, take a break for 30 minutes. The discussion is still not done. I mean, temperate cyclone is over. The concept is done. What we need to do right now after the break is this. We're going to compare tropical and temperate cyclones. After that, I'll give you a mains question, 15 marks. You should write it right now. I will see. Your notebook is there. You're caught. Others, I don't know whether they will write, but I'll definitely ask you to write. So you will attempt a 15 marker. I'll give you 7 to 8 minutes. After 7 to 8 minutes, let's discuss how to write a mains answer, how to draw the world map for mains answer writing also, how to compactly draw. Once that is done, I'm going to take you to climatic regions, 3 more climatic regions, Savannah, Steppe, and Siberian. After that is over, we'll see what are thunderstorms. Is it clear? So take a break for 30 minutes. Reserve your questions. I will definitely take them at the last, possibly 6:45, 7. So half an hour, we'll meet again. Reserve your doubts, I'll take it up later. Slide 25, 26, okay. We shall continue right now. Let's start with the lesson plan. What are we to supposed to look at in the next 2 hours? Last half an hour will open for discussion. Okay, so where we stopped. Fine. 31. So lesson plan right now, I just have one more point. See, this last segment, I'm going to teach a relationship of jet streams with extratropical cyclones, a relationship of frontogenesis with jet streams. Okay, that's one small segment. So we'll finish that, jet stream and frontogenesis. Then we look at comparison. After comparison, we'll try one question. Okay, then world map drawing. Second section of the class. Okay, once you're done with the cyclonic systems, then we move to steppe, savanna, and then Siberian climate. Done with this. Then we move to thunderstorms. Thunderstorms is a related concept, so we can finish thunder, lightning, and then it's not, you don't have a perfect mechanism, but where is their frequency and all that. Okay. If time, I think this should be perfect. If time permits, then I'll tell you about the next topic. But 2 hours, I think this is the maximum we can do. Okay. So let me finish with this topic. See, just like we have the relationship of ITCZ and relationship of equator with hindering tropical cyclones. Fine. Jet streams can actually help frontogenesis, or jet streams can hinder frontogenesis. Jet streams will be the final determinant whether a frontogenesis will be successful or not. Okay, so we are going to link a upper atmospheric wind system with something of a circulatory system which happens at the surface. So how does my horizontal movement affect my vertical movement? Okay, so very interesting concept. And again, I'll tell you, I'll try to explain. If you understood, good. You did not understand? Very good. Okay. So before that, let me start with the bike ride. The road. People listen. Road is there. In this road, you're driving your bike. Bend is there. Until this straight road, here also straight road. This is bike. Assume. When you move here, in the straight road, you'll follow until this segment of the road. Straight road, will you go fast or slow, man? Fast. Straight road will come first. Bend is coming now, what will you do? You slow down. Put it. Bend also faster, then you'll hit and go somewhere. You'll be in a hospital only. So you'll automatically slow down. So when you move from a straight road to a bend, automatically you reduce your speed. No? This is also part of bend. Bend again, speed will be slow only. Again coming to straight road. Here what will happen? Speed fast. A normal human being with certain level of common sense will drive like this only. Okay. Any doubt here? Bike riding in a bent road or a bend. If you're done, use the word finished. Some genius people will be there. At the Sunday in Chennai road, you can see. If 7:30, you go outside. You've seen people riding, racing. Don't worry. You just any main road 7:30, just stand outside. Look in Chennai. Not distant beach. Every area they'll be racing, including Anna Nagar. Main road you'll have to stand. Their biggest achievement is beating traffic police. Well, I don't know what type of achievement is that. Camera will catch them anyway. People listen. The same principle can be applied for how jet streams will influence the vertical systems. Now let me draw jet streams. And where are jet streams? Jet means jet streams flow in the upper atmosphere. So let's say this is my tropopause. Okay. Listen, let me finish the discussion. Okay. Then you draw the diagram. I'll give you time. I want you to listen first. Either ground surface. Listen first. I'm talking about a very fast wind at the top. So let me draw a jet stream. Jet stream is meandering, no? Meandering jet stream, moving like this. Long, narrow, meandering, fast-flowing geostrophic wind. See, just like we saw with reference to, a bent area or a curved region, your velocity will change. So similar to how human beings change, it's normal for any physical system also, any system. So you will see that as the jet streams moves around this bend, around this area where there is a clockwise rotation, right, this region, here there is change in velocity. So it moves from a higher velocity to a lower velocity. People visualize this. Visualize a small area, a narrow channel, large number of air molecules are moving in. Okay. Once you slow down, your carrying capacity will reduce. If I'm fast now, I'll be able to transport large number of air molecules. Once I slow down, I cannot transport everything. So which means some air molecules will drop down. Listen carefully. Because of reduction in speed, naturally, there is more drop, okay, of air. Because they're not getting transported. So air is descending down, right? This region where there is a clockwise rotation, okay, this region is what you call as convergence. This one, this area, okay, right here. I'll write it here, convergence. Let me finish, wait, convergence. Now this is the first part of the bend where air is descending now. Now at the same time, when you take the second part of this bend, okay, it slows down and increases velocity, slow to fast. Now, what happens is I slowly increase my speed. Now, in the upper atmosphere, I'll be in a position to transport more and more molecules. If we transport more and more molecules, space will be created. One pen is here. I'm increasing my speed. What I do is slow to fast, I take both these things and go. Now, space is there. Nothing is there here. I don't know why they place a duster in this area. Nothing is there. Get the idea? So, once things move out, here space will be created. To occupy the space, air will come from top. Air will come from here to here. Air will come from here to here. You tell me, blue color, green color, which is low pressure? Surface level, which is low pressure? This is my low pressure system, people understand. Frontogenesis can happen anywhere. Frontogenesis can be here. Frontogenesis can be here also. But understand, the second frontogenesis, no. This will properly develop into a proper cyclone. The reason is, this is where your warm air mass can move up. If frontogenesis occurs here, this is my high pressure, air is descending down. This will destroy the frontogenesis. Meaning makes sense. So jet streams can decide where my frontogenesis will properly develop into a cyclone. So even if frontogenesis is there, completion of cycle, formation of cyclone is not possible in all those areas. Here only proper rotation and rising up is possible. Here it will just get clogged, stagnated and disappear. If they just simply get clogged, there is no rotation, no change in weather system, there is no invasion. After a point of time, they will mix and dissipate. Okay, take this diagram. So jet streams can influence climatic system. We move from slow to fast. The slow fast now, please understand, fast not here. You're increasing the speed. Increase the speed, you'll take and go. Here there is low pressure. Green is low pressure. Very good. So jet streams can influence formation of, or proper formation of temperate cyclones. So this pink color thing is jet stream. The height can be 7 to 8 kilometers. This one, this height, 7 to 8 kilometers. Okay. Have you gone to Southern Hemisphere? Has any one of you went to Southern Hemisphere? People keep asking what happens. Anyone has traveled below the equator? Anyone is there? Sir, I've gone to a place below the equator. One person, at least one person should be there. Sir, I studied in South Africa. And I studied in Australia. My cousin is there in Brazil. Anyone? Green and blue seems very similar. Why not orange? Okay. So one person has went to Papua New Guinea, but Papua New Guinea is still, it's very close to equator, right? But at least you went till Papua New Guinea. Stopped at Pondia. Pondicherry, man. That is not Southern Hemisphere, man. Pondi, there is no country as far as I know. Pondi means Pondicherry only. Pondi, a country is there. Nishit. Pondicherry, how much Southern Hemisphere? Even I have been to Pondicherry. Southern Hemisphere, I asked. Every time I explain something in Northern Hemisphere, they're like, Southern Hemisphere, what will happen? One person has at least went to Papua New Guinea. Fine. That's good exploration. Nice. Those who are wondering where is Papua New Guinea, don't worry. It's just close to, I think that country I didn't teach you. You would remember Borneo, Sulawesi and all that. So the island which is immediately next to Indonesia. Okay. Oh, the liquor stopped the travel. Yes, man. That is the only thing there. You go there, you can't progress beyond. Shall we start comparison? Ready? Diagram is done. So let's start comparing your tropical and temperate cyclonic systems. Right. So feature tropical cyclone, temperate cyclone. Okay, first is latitude. The latitude of tropical cyclones, 5 to 25 degree north-south. This is 45 degrees north-south, 45 to 65 degrees north-south. Okay. Reason for formation? Well, the reason is latent heat. So that is the reason it's able to really become very, very powerful. And here there is difference of temperature of air masses. Okay. Frontogenesis or presence of fronts absent in tropical cyclones, present in temperate cyclones. Okay. Basic differences. Latitude, formation, frontogenesis. Then location meaning where can they form? See, tropical cyclones can form only over water bodies, only over sea, because they require large amount of moisture. We saw yesterday. Temperate cyclones can form both on land and sea. Doesn't matter. It doesn't matter about the basic surface, because at the end of the day, air masses should collide. Air can collide over land, air can collide over water. Doesn't make a difference. Once you copy the 4 differences, use the word finished. Yeah, thank you. So 4 more done. Next. Size. Okay, tropical cyclones are smaller. These are very large. Why temperate cyclones are large? Because they are extensive areas of air masses. Velocity of tropical cyclones is high. Velocity of temperate cyclones is low. Is it clear? Smaller body. So smaller body can rotate very, very faster. Talking about your movement. Movement is mostly governed by your trade wind system. Trade winds. Mostly trade winds. Here it is westerlies. And jet streams can also move the systems. Is it clear? Proceeding further, influence. Like what are the other factors which will influence their formation? Well, you have equator influencing. Okay, you have your ITCZ influencing. Here, jet streams can influence frontogenesis. We just saw it right now. And if you look at weather pattern, so weather pattern in tropical cyclone is very, very simple. We had a heavy rainfall area, we had a no rainfall area, then we had a heavy rainfall area. This is the order, no? Here there was a proper order. You had light rain, then you had no rain, then there was heavy rain, and after heavy rainfall, there was no rainfall. So there is more complexity in weather patterns. Simple weather pattern. The 9 points are there. See, if you write large, small, you won't get marks. Find data, how much is there? Fill in the blanks. What is the average width? What is the average velocity? Just put question mark by the siren key. Simple thing. Once you've taken this also, use the word proceed. We'll discuss one question. I've taught cyclones now. No doubt in cyclones now. So you should write a question if I give you. Mains question. Previous slide once more. I will show. Question make mistake means. Slide number, previous slide. Make it faster. Anyone needs previous slide? Shankar. GG. Done? Okay. Ready? 8 minutes. $15 marks. Try the answer for 3 pages. You have time for 8 minutes. 480 seconds. Start now. Don't ask me what to write. If I get even a single question what to write, I will kill you. Eight minutes exactly. Your notebook is here. I am going to check. 8 minutes time. Start. Yeah. Start. We'll see. People try, only then you understand what mistake you're making. Half time over. 4 minutes gone. Last minute. Give a notebook.
Only one page.
One page you have written. Good. First point is correct. Second, not always. Third point, good. Not bad. Not bad. People, hold on. Enough, enough, enough. 8 minutes over. 8 minutes over. No, that's what you need to improve. Writing speed will need to improve. People, listen. Listen now. I have not discussed any main answers so far for your batch. Batch 3, for your batch, did I discuss any mains answer writing? Anyone from batch 3? Just say yes or no. Okay, we haven't seen any question. Fine. Okay. See, some fundamentals I'm pretty sure other faculty might have talked to. Okay, just some fundamentals regarding mains answer writing. Then we'll see what is expected out of UPSC. Okay. See, first of all, your page limitation will be there. Like any question, if you're going to be allotted only 2 pages or 3 pages, then after 2.5 or 3 pages, the next question will be printed. So there is no scope for you to ask for any more extra pages. Second one, UPSC will clearly tell you need to put your content only here. These regions you're not supposed to write anything, so write only here. Looking at this, you might feel, oh, the space is very less, I can't write anything. People understand even for filling this space in 8 minutes is extremely difficult. Think about this stuff, this for 3 pages, close to impossible. Number 3. When it comes to mains answer writing, what is essentially expected? Okay, will they expect only one thing? Answer to the question asked. Answer to the question asked. Don't say anything what you know. I'll give a simple example why it is structured like this. You have become foreign secretary. Become foreign secretary or become, let's say, defense secretary. Defense secretary will be perfect. Defense secretary there. Prime Minister of India is there. If Prime Minister of India comes to you, critical situation, you have only 3 minutes. Prime Minister of India asks you, see, there is trouble with China. Give me an evaluation or give me an assessment of our current ground level situation. If there is attack on the eastern sector, will our forces be able to handle? When he says this, if you say, sir, currently India's gun production is at so and so much thousand, we have troops stationed in Bhopal. My air force system in Trivandrum is working well. If you give this answer, what will Prime Minister of India say? See, understand, the 3 statements you gave was correct only, but problem is you have not answered the Prime Minister's question. Prime Minister of India can give you only 180 seconds. He may give you 300 seconds. In that time, as a bureaucrat, as a diplomat, your job is to properly answer him. Okay. There will be several critical. You might be in administration, you might be a police officer. A question is answered, you need to take a decision based on the input what you have, what you can do. That is why answer to the question asked. I'll tell you what you should not do for the question. This question. If you have written description of tropical cyclone, description of temperate cyclone in detail for 1.5 pages, answer is wrong. If you've talked about frontogenesis, all the diagrams I've introduced you, you've written there, answer is wrong. The only focus of the answer is 2 questions. I mean, the only section is 2 keywords. First is evaluate. Always look for the keyword when you see the question. Evaluation, I evaluate, 3 keywords. Evaluating your paper, assessing your paper, examining your paper. All 3 things mean one and the same thing. When I evaluate your paper, I'm actually providing marks whether it is correct or not. Yes or no? Similar to that, they give you a statement and ask you to evaluate. You are assessing or examining or evaluating the truthfulness of the statement. Tropical cyclones are more destructive than temperate cyclones. Is it true or not? That should be the answer for the 3 pages. Simply write description of tropical cyclones, temperate cyclones. Answer is correct. Troops are stationed in Bhopal. You have not answered whether we can manage China on the eastern sector attack. Get the idea? Number 2. Entire focus of the answer should be here only. Is it more destructive or not? You will tell me, we haven't taught us. This question answer writing, you have not taught anything. Content I given you, all you need to do is how to present the answer. Again, you know what, one more mistake you would do is not giving a proper introduction. I will tell you why introduction is necessary. You know why you wouldn't write a proper introduction? You may have started the answer without even defining a cyclone. You didn't define a cyclone, no? Okay, why? Because you've already assumed that the person who is correcting your answer sheet knows cyclone. He'll be an expert. Why introduce to him or why give him the information? What exactly is a cyclone? Let me tell you this. What is your major graduation? BTech. Everyone would have finished BTech, right? BTech, na school you would have studied chemistry, no? Huh? Give me if I ask you a question, 10-mark question, give me the features of Niels Bohr atomic model, 10 mark. Will you be able to write an answer today? 1 point maybe you can tell. Atomic model something. 10 points or 2 pages if I given, I will you be able to write answer now? Today. 1 page, you can write about Niels Bohr something. You can't write 10 pages. But 7 years ago, 8 years ago, when you were in school, you'll be able to write now. Because everything was memorized. People understand this is the problem. 10th standard, listen here. 12th standard, undergraduation, post-graduation, PhD. Okay, then working for over 10, 15 years. The person who's correcting your paper will be in this level. Or PhD, post-graduation, PhD would have finished actually. That person or experience will be having for 10, 15 years. He will only go for UPSC paper correction. His age will be 44, 45 or even more than that. Is it clear? Now, when he's sitting and correcting the paper, do you think he'll exactly remember what is a cyclone? You get the idea. And remember, the content comes in General Studies 1 paper. GS1 la history teacher might correct the paper. So sociology paper might correct paper. Geography faculty correct papers, no problem. What if history faculty corrects paper? Everything is there. General Studies 1 la all 20 questions, mixture will be there. So never ever make the assumption because he may not exactly remember what it is. That is why introduction is important. But introduction is not the entire answer. You need to introduce in such a way that it is very, very crisp. Just put the definition, what exactly it is. Problem is this, information is too much. I can't present in exactly half page. You can present in half page. That is where diagrams come in geography. Let me explain. Let's say there are 3 pages. Cyclones are low pressure systems with a velocity of greater than 120 kilometers per hour. Question la tropical cyclones, temperate cyclones are there. We need to introduce. They are broadly classified as tropical and temperate cyclones. What people will do is, tropical cyclones are present in the latitude. See, I know the video is blood, it'll become automatically okay. I'm not writing anything on the board. Listen to my voice, listen to this. After introducing, you should tell what is tropical and temperate cyclones. What will people do is, tropical cyclones found between latitudes of 5 to 25 degree north and south. Temperate cyclones found in latitudes of 45 to 65 degree north and south. Yes, I also know that. You write that you think it will be easy for him to understand. It's your duty to make it easy for examiner to correct your paper. See, it might be your life. For him is just an answer script. He corrects the answer script, he will get so much rupees at the end of the day. India diagram comes. You write 525, you write 45, 65. That is not a problem. You put a very small map, people. Just a horizontal fix. See? Okay. Small one. 7 seconds, that's all. Map done. After that, equator, Tropic of Cancer, Tropic of Capricorn. 1 second. After that, put, just put circles. Okay. These are, tropical region is there. Tropical cyclone. Meaning makes sense. Above, put circles. These are temperate cyclones. That's all over. He sees the map now. Heading should be there. Location of cyclones or types of cyclone. Type cyclone. Tropical, temperate. Proper fixes there. 5 to 25 degree, 45, 65 degree, and you are not making him think. You are showing to him, sir, see, sir, I have divided for you. I have understood the question. This is my introduction, sir. Tropical, temperate. Tick mark. 1 mark, immediately he'll decide, okay, first part is correct. Ipo, all the content always I told you, don't dump content. Tropical cyclone is this much, temperate cyclone, frontagen is other. This is UG style. UG exam, whatever question they ask, we will learn only 5 answers, we'll go and dump it and come, mark will come, they'll put pass. Inge answer to the question asked. Start with the most basic thing. Sir. Point 1. Comparing tropical and temperate cyclones. Tropical cyclones have higher velocity. See, don't worry about video quality, focus here. I've already started. I'm not writing any points. Any major points. Listen here, listen to the audio. Tropical cyclones have extremely higher velocity. Because of higher velocity, there is more capacity to cause destruction compared to temperate cyclones. Simple point, the velocity is 2 times higher, 3 times higher than temperate cyclones. Point done. Number 2. This is where you use your mind. Tropical cyclones occur in the latitudes of 5 to 25 degree north and south. Written this now. After writing, these regions have high population and high population density. For example, countries like India, Pakistan, Bangladesh. which means more population will be affected. Yes or no? Point correct only. No? Number 3. Tropical regions, developing countries are there, or developed countries are there, tropics. Developing countries. In the tropical region where tropical cyclones are more frequent, developing countries are more. Since developing countries are more, they won't have money, which means they do not have enough financial capability to overcome or mitigate against the disasters. So destruction of tropical cyclone will be higher. On the other hand, in temperate cyclones, we have Scandinavian countries, Denmark, they can prepare better for the upcoming cyclones, or they will have better weather monitoring systems, better prediction systems. You can write, no? So there is more destruction because of tropical cyclones. Number 4. What is the question? Tropical cyclones cause more destruction than temperate cyclones. Did I say more destruction to human beings? I simply said destruction only, no? Tropical cyclones can affect, due to their high velocity, coral ecosystems, mangrove ecosystems, entire ecology, the entire ecology and the biosystem which are present in your equatorial climatic region of Indonesia, your Caribbean Sea, all of them will get affected. Anga puttu location, spatial factor should come. Meaning makes sense. Number 5. Now jump to physical factor again. You can say in tropical cyclones, based on the structure, there are 2 regions of heavy rainfall. Okay, only 1 region of less rainfall. But if you take your temperate cyclones, there is only 1 region of heavy rainfall, and all the other regions there is no rainfall. Correct? So 2 regions of heavy rainfall. Cumulonimbus cloud, cumulonimbus cloud. Only I there is no rainfall. Okay. Here only 1 region of heavy rainfall. 2 is greater than 1. Hence there is more destruction. Is it okay? Once written is fine. Again you can say, well, at the same time. Okay. Temperate cyclones are also becoming more powerful. And evaluate question. Not necessarily that every point should be positive. Temperate cyclones are also becoming more destructive due to problems of climate change. Cyclones are very disastrous phenomenon, and as part of international convention, Intergovernmental Plan on Climate Change and United Nations Framework on Convention on Climate Change, the entire world based on Paris Climate Agreement of 2015, we should take constructive measures for reducing the frequency of cyclones. Full stop. Why do you say Mark won't come? You tell me any point was complicated. Sir, this complicated point my brain can't discuss. Simple or complicated? That is what I'm telling you in mains answering. Mains answer writing, you don't need PhD people. Economics, inflation, I need to write now. I update fully inflation, but the thesis are not needed. Basics of inflation, basics of geography only. You get the idea. In mains answer writing, this is what you need. Answer to the question asked, mark will come. Simply dump content, they won't give you anything. Meaning makes sense. So always remember, it is not about all that. That's why people tell you, all these toppers, if you have looked at the videos or any seniors you refer, they'll tell you, you take 3 to 4 books or 3 to 4 books. Now every subject they'll tell you 1 book. Material you keep restricted. Same material revise again and again and again. Writing, practice only it will come. Writing you note these ideas, these points you refer any textbook, no textbook will you. Where will you go and think? I thinking process only you need to develop properly. So mains answer writing is different, learning is totally different. That's why people always tell you, material if you're learning, keep your material limited. Be it geography, be it history, be it polity, 1 book or 2 book enough. Beyond that, polity, 15 books, 20 books you refer, geography, 37 books you refer, same, cyclone will be same in every book only. The extra data they might give, one new cyclone name you will get, okay, that it caused destruction in 2017 or 18. Beyond this, mains answer writing is not magic. It is only logic. Okay. Sense and sensibility. That's all. If that is not there, you won't get in. That's all they expect. See, what UPSC expects is an individual who will obey orders properly, who will serve the society. Okay. Who has some common sense, because that's what is lacking. You have that, people will get you in. That's what is expected. As I told you, a bureaucrat or a diplomat is to answer the question asked. That Bhopal answer no, or I'm having Air Force in Trivandrum. That is the answer of a businessman. You get the idea. There you need to convince the consumer. Do you have 100 kilograms of rice? No, sir. 100 kilograms of wheat is there. You buy this. Other businessman answer. This is UPSC answer. You understood how you need to write the answer? No. Shall I proceed further, people? Always remember, it's not about learning too much. Learn limited. Write sensibly. You'll gain marks. If you're ready, use the word proceed. Okay. Is there any generalized method to write all geography answers? No, man, there is no generalized method. Always remember, there is no, when it comes to mains answer writing, prelims is subjective. Mains, I'll tell you one thing, there is no right answer, wrong answer, right method, wrong method, nothing like that. There is only relevant answer, relevant method of answer writing, irrelevant method of answer writing. That's all. Irrelevantly you speak, mark won't come. Relevant answer you give, that's all. There is no specific method. If 1,000 individuals are clearing UPSC in single year, 1,000 individuals will write in different ways. Some may not use diagram at all. Some might use more excessive diagrams. Some like writing in bullets, small lines. Some might like writing in paragraphs. Idea is you answer to the question asked. It doesn't matter how you answer. Some paper will be content driven. They'll put so much of data. Some individuals like content driven. Some paper analysis will be there. Some areas content will be shallow, diagrams will be more. So it's not that this method only is successful. That is why it is wide open. Only thing you need to remember is relevance of the answer. That's all. If you get that, you're in. When can we start mains answer writing practice? You need input of at least 4 months. 4 months is over. The batch started. You need at least 4 to 5 months. Only then content will be there. That much content you have, then you can practice. Previous year UPSC questions is enough. Okay. Now, before I proceed, one thing about handwriting. People ask me always. People remember handwriting is different, presentation is different. You don't need beautiful handwriting. You need a good handwriting. For something to qualify as good handwriting, 2 conditions. First condition, it should be visible. It might think to be a joke. I've seen several papers where it's so difficult to see the font. Font size will be very, very less. Actually, my personal opinion, one of the reasons I didn't get through, especially second and third mains, my handwriting. This font size, no, this used to be like this. I'll write like this only first. This is my handwriting, actually. I'll show my papers 3 years back. I had to force myself to change. I was like, one page, the entire page, only 10 lines come, 11 lines come not. I will increase my font size, I increased. I possibly made it visible. See, why? Because person correcting the paper maybe are wearing bifocal lens for 48 years of age, back pain. 7 papers you have corrected. 8th paper, 7th paper is good. 8th paper you take, font size not able to clearly see. Why should he read paper? If he puts less marks only, verification will be there. Every question he might standardize. 20 questions are there. Every question 3.5 marks. That's it. 15 marks, he'll put 4.5. You'll get 70 marks, you would not understand where you went wrong. First one, it should be visible. If your handwriting is small, don't lose 2 attempts because of, like me. Is it clear? After improved font size, I never cleared prelims. I attempted once. Okay, in the last 2 years, I couldn't run. Listen here. Number 2, it should be legible. Readable. That's all. It need not be beautiful. Sir, italics I'm learning. Why learning italics? Yeah. If you can read and understand it, is okay. That's good handwriting, man. This is good. Nice font size also. Okay, that thing you maintain. Okay. Regarding presentation, paper should be clean. Clean, na? See. Script edutha. How not to write? Not to write ango, it won't be there. People will start here. They'll do this and keep. I should read each and every point. I should circle all the points. I should read carefully, tick all. Then I should say very good points and give you marks. I won't do that. I would not even take the strain. I will look at the paper. This 2. Oh, that's all. You break it down and present. Ideal paragraph size. If you go by paragraphs, ideal size is 4 to 6 lines. All the finger line spacing they taught you in your school now. Proper finger line spacing should be there. Look at the paper itself. I will know this first and second point is delineated. You want to go for a diagram, two ways to fix. Proper is horizontal fix. You want to draw a world map, this way of fixing. You want to go for a process diagram. For example, Indian monsoon, you're drawing. Indian monsoon, you're writing. Indian monsoon, this method only I use. If there is process they're asking, I'll draw 4 India maps. Small India maps. Is it clear? 3, 4. That's all. 4 India maps. Here mechanism is slowly. For jet streams will come, cyclones will come. What I'll do is for each thing, I'll write the content here. You just look at the diagram, tick, 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 that's all. It will flow automatically. Meaning makes sense. Horizontal fix, world map, you're going to fix like this. In economics, you can do the same thing. Economics method is this one. For example, you can use pie chart. So, economics answer you're writing. Okay, you want to introduce some vertical data, na? Go for fix like this. Pie chart you can say, for example, GDP contribution, this much percentage is there. This much is given for defense, this much is given for, so you read this now you can shade, pie chart. Or you can go for a graph like this. For example, GDP has increased over a period of time. X-axis, Y-axis. That's a simple diagram. Economics. You can use this for any carbon dioxide emission has increased. Okay. Or GDP has fallen down because of COVID-19. COVID cases has increased. Basic diagrams. Okay. Either clean paper. Meaning makes sense. Don't write simply. And always remember, border should be there when you're drawing a diagram and heading should be there. There is no need for me to take effort and look at what you have written. That will be the attitude of most examiners. You want marks, you show it to them. I've learned, I've broken it properly, evaluate it. Easy, na? Keywords are there, you can underline. Underline, underline, underline. Show it to him, sir, these are the points. He'll look only here. 3 answers, you convince him. First 3 answers, you've convinced him. Answer number 4 to answer number 20, free flow. You'll make the person happy. 6.5. 8.5. It will go like that. Basically, the first 4 answers, first 5 answers are very important. Basically, so this is regarding presentation. Always remember how to do it. Don't make it very clumsy. Make it structured. You might be thinking this seems like school. That's what we were instructed in 7th and 8th standard. Presentation is important because it is logical. The human brain, I need not work. It's your paper. You want marks, you present it. That's all. Okay, the person who's correcting the paper, there is no accountability factor. You cannot get your answer copy and see whether the person is evaluated properly. You just hope that he's evaluating well. Because the evaluator is a human being. And he has his own tiredness. Last paper of the day, how will you evaluate, man? 45th paper, back pain is there. 8 hours you're evaluating. Just finish it off and go, no? First paper in the morning, evaluation will vary. There is a high level of subjectivity in evaluation. So you make it easy for them. Yeah. Immediately before lunch, things will be different. Problem and family, evaluation that day will be different. Before you 5 good papers, your paper, gali. That's all. Before you 5 bad papers, your paper, even if it's moderate, you will get good marks. So much of subjectivity in mains answer writing. So I believe it was useful, even though it was not only geography. Okay. So when you write answers, keep these things in mind. It's just few basics. Relevance, keep it simple, keep it concise, and present it better. That's all. And if you want all this, you should learn well. Okay. So world map drawing. Huh? Yes, yes. Pen types you can use anything. There are no restrictions. I think green or red, I think the ink colors are there, no correcting colors. That alone is risky. Black and blue pencil, there is no problem. No issues at all. See, you can use the black change, blue change at all. Like you can use anything. Depends upon your time management. Because pen you'll need to switch. If you are very fast in switching pens, you can write. No problem. Black, blue pencil. I use only one color. I am not very good in switching. Some people will be there, no? Both things they will use in one hand itself. This pen will go in. They'll write. This will go. They'll write. I look at those people, I get very scared. Adala I can do. I use only single pen. One pen will be enough. That's all. And this thing, should I use ink pen, ballpoint pen, gel pen, use anything you want. It depends upon your script. There is nothing like, one person was saying, you should never use ink pen. If you use ink pen, they won't evaluate. 3 mains I wrote with ink pen only. They evaluated my paper, I got marks. So don't believe those rumors. World map. Drawing. See, objective of world map is to finish in a short time. Simple steps. It should look like world map. That's all. North America. Step 1. Start from left. You know bird? Bird. Bird is North America. One beak you draw. Wait. One beak you draw. Huh? Wings. That's all. Close. Step 1. I'll repeat again. North America. Beak. The bend body of the bird. Finish it with wings. That's all. A beak, body, wings. Finish. Ink not drawn. Draw first. Finished. Can we use ink pen? Yes. I've written ink pen, man. No worries. They will scare you. Ink pen if you use now, if rain comes, all ink will be washed away. You won't get. If rain comes, all papers collapse. They'll reconduct the exam again. Stupid instructions some people will give. You know. Is it compulsory to write 3 pages even though we gave our best within 2 pages? Not required at all. Never ever try to fill page simply. Simply you fill now, they will get angry. In a 2.5 page only there, sir. Out of 4 pages, I have two cut only. Fine. Write what is required. Enough. What you have. You can use ink pen. Okay. How did your optionals go? No, it's not just about optionals, man. All the papers I was short of 10 marks. I wished I had learned these things before those 2 mains. You know? See, after step 1, step number 2, drawing South America. South America is very simple. C. Extended area. Finish. That's all. 1, 2, 3. C. S. C. That's it. Number 2. Simple, no? See, when it comes to Africa, this is where people make mistake. Listen. The northern portion of South America, equator will pass through. This equator will cut Africa into 2. So you should draw it in such a way that Africa is fixed. Center portion of Africa and the northern South America should cut properly. Top South America. So drawing Africa separately is this. Draw one line. One C. One U. One C. One U. That's all. Complete the U. Again, line. C. C. U. That's it. This C has to be slightly out. That's all. 4 steps. Line, C, C, U. Done? We just try to fix it there. Fixing is the only issue. Fix it in the middle of South America. Listen here. That's all. So you take Africa, the center portion of Africa and South America should be there. Step 3. Exactly should cut. This one. See this line? Step number 4, Middle East, Arabian Peninsula. So if Africa is here, listen here. Step number 4, here you draw a boot or a shoe. That's all. This is Arabian Peninsula. Done? Meaning makes sense. So this area, this region is there. This is Red Sea. Red Sea just extended, close. One leg, that's all. Draw one leg. Arabian Peninsula. Shoe. Right shoe or left shoe or something. Number 4. Shoe over. When we draw India, only people get excited. Why? Bharat, no. All that energy will come. They will draw India in such a way it is bigger than Africa and go. Control your emotion. Isn't it? See, when you draw India, always remember Gujarat. What thing is, why Gujarat? You see the shoe portion of Arabian Peninsula, no? This is where Tropic of Cancer will come. This will exactly come and cut Gujarat. Okay. So this shoe is there, shoe tip is there. Shoe tip and Gujarat should be in the same line. So Gujarat. Okay, just draw one. 2 things are not required. Just draw one. That will be enough. Once you have drawn the tip of Gujarat, listen here. When you draw the peninsula is nothing but a V. One V you are supposed to draw. What people will do is put the V like this and down. Don't do that. India does not even reach equator. No? So you draw a small V. That V should not even touch half of Africa. That's all. Not even half of Africa. If you draw this line, for example, I draw this line. You draw this line, this V shouldn't touch it. Should be above the line. So draw the shoe, extend Gujarat, V. Gujarat and the shoe should be in the same place or almost in the same line. So step number 4, step number 5. Step number 6, extending to Malay Peninsula. This area is there. Simply put an extension line. And this line can go till the middle of Africa because this region is Malay Peninsula. Done? One extension line you drew. After you draw the extension line, people listen. Draw the extension line, close the extension line, put one more U. This U, that's all. This is your Indochina Peninsula, Laos, Cambodia, Vietnam and all that. That's it. Put one U and just close it. That's it. 6, 7. Okay. Step number 8, Sumatra. Right there. Malacca Strait. Sumatra, like exactly where you at the Malay Peninsula, just there, just draw an island like this. The Malay Peninsula is here. Just draw Sumatra. Just one, column like this. Sumatra is done. If you want, it is left to you. Can simply draw 2 circles like this just to represent Indonesia or leave like that. I usually don't put these circles. Until and unless I want to denote something in Indonesia, don't draw these 2 circles. But if you want, you can say Indonesia is there. Now, Australia. Australia had Batman, Batman. I am Batman. That's all. Looks like dog's face only. This one. So 2 horns. Just finish it like this. So where it comes in southern Africa. Tropic of Capricorn passes through South Africa, it will cut through Australia. So top of Australia should be here. Listen what happens. The 2 horns are there now. So exactly here. That's all. Proportionality. 8. Step number 9. When people come to Europe only, their hands will shiver. They'll be like, Europe is an extremely complicated continent. Balkan Peninsula, Italian Peninsula, Iberian Peninsula, nothing. Don't think too much. Listen here. You had this horseshoe. No? Horseshoe was there. From this horseshoe extend, just one line. After moving north, just put 2 bumps like this. That's all. Horseshoe's there now. Move north, just put 2 bumps. That's all. 2 peninsulas. Just 2 peninsulas are there. Finished. 2 bumps. After 2 bumps, extend, finish. This is my Scandinavian region. Close. That's all. Step number 10. 9, 10. Scandinavia, just put one like this. Okay, looks like an animal. Yeah, that's all. This will be enough for exam. 7 to 10 seconds. Practice very hard, you'll get it in 7 to 10 seconds. Now, if you draw the lines, look here. Equator. Indonesia, it will cut. Africa, it will cut. South America, top, it will cut. Tropic of Cancer, Sahara Desert right here. Right here. Tropic of Cancer, it will pass the Arabian Peninsula, it will cut India into 2. Tropic of Capricorn will be here. South Africa, Australia, South America. That's all. This is the proportionality. Put the map now, then it will be looking like this. If you don't have the proportionality in diagram, if you draw the Tropic of Cancer, Equator, Capricorn, it won't look well. You can't fix exactly. But tropical cyclone, here I can mark tropical cyclone. So I can simply say tropical. I can simply say temperate. Job over, no. So there is no confusion which countries are getting affected. Okay. The 6 and 7 pass through equator. Yeah, 6 and 7 does pass through. 6 passes through, 7 not exactly. But it's not a problem. Okay. How to attempt unknown questions? I will answer that. How to attempt unknown questions. Wait, I will show you. Done? Shall we try one more time? See, trick in drawing map is this. Don't think while drawing. If you start thinking, you will start to put details in your mind. How exactly should I draw? When you draw, keep the pen in North America, take it after completing Russia. See? That's all. Finished. Finish it immediately. You think, Ayo, North America, this part slightly here. Adalla. Finish, that's all. If you draw now, it won't be wrong and all. Acceptable limit is there, no? 7 seconds, this only will come. Make it very fast. Start, immediately finish. Don't strain. Speed is not working. Say draw slow for first time. If you think, you will make mistake. If you think, only details will sit in your mind. Okay. Gobi Jagan, will drawing the latitude self with proportionality? No, man. Draw that much level of perfection will take time. Is this a perfect map? No, I myself know. Perfect map you want, you take time. See, objective of putting world map is just for answer writing, just for showing the examiner. 7 seconds. Shankar sir will scold me even if he teaches 7 seconds. He'll always tell 4 seconds for world map, 3 seconds for India map. I'm giving you 3 seconds extra. He will kill me. Okay, 7 seconds only. Got scoldings from him. I am actually more detailed. His map is even less detailed than this. Again, North America. Okay. South America, Africa, Hoods, India, Malay Peninsula, Australia, 2 peninsulas, Siberia. Again, see, perfection won't be there. Okay. Equator, Tropic of Cancer, Tropic of Capricorn. But acceptable. 7 seconds. It'll work. 15 seconds. You can reduce, man. See, I'll tell you one thing. Practice consistently for 3 days. 3 days consistently. 10 times you draw, it'll come. Okay. Map of India, Helen. Map of India, Indian geography, we'll see. Don't worry. Okay. India maps? No, India. This is the idea. Hint is this. Gujarat. See, not because Prime Minister is there. Okay, it's an easier place. Gujarat. V. Only thing about India is Gujarat and Tripura, both these regions, Tropic of Cancer will pass. So after finishing this, just put bend. So if you draw Tropic of Cancer, it will cut India into 2. Go to Arunachal Pradesh. Close. Na? Rajasthan. Sikkim. Then just put Jammu and Kashmir. Over. Cut India, north and south. Gujarat. 2, 3, 4, 5, Kashmir. One, 2, 3, 4, 5, 6. Practice, that's all. This will take 4 seconds. I take 4 seconds for this. That we can do in 7. No need of other countries. You're appearing for Union Public Service Commission. They will ask you world or India only. Japan, they ask now, you simply draw Japan, the Japan. Da. 1, 2, 3. The Japan, that's all. 4 islands, that's it. Okay. Will it be okay to draw tropics and equator first and then draw the map? You will consume more time. That's when you become conscious. I'll tell you the mistake again. You're looking at the beauty of the diagram. I know these are not beautiful. These are not beautiful. Fixing, that's all. Here, if I want to draw soil, I'll say these are regions of alluvial soil of India. I'll put alluvial soil. Examiner will see, okay. Adhik the map. Perfection today. Okay. No need of other countries. You write Uzbekistan Public Service Commission. Try to draw Uzbekistan. Until then, not needed. See, mains answer writing is equally essential. That's why I haven't taught content, but I believe this was useful too. I hope so. Okay. Never focus on beauty. Focus on time. It's always about time. For monsoon, sequentially, if you draw 4 India maps, 12 seconds. Beyond that, you shouldn't spend time. No. How much of current affairs based questions does geography have? I can't give you a percentage, Avinash, but it's like, let's say 50%. 50% is like, when you say current affairs, now questions are becoming more and more oriented towards environment. For example, you take this more destructive. Okay, it's both physical geography and human geography combined. So I would say 50%. If 8 questions come, which is the normal, you get close to 4 questions will be related to some environment. Impact of climate change on mangroves, impact of climate change on corals. How does this industry changing? So more focus on change is there. 8 questions. 8 questions out of 20 in general studies 1. 8. Standard for last 5 years. Same 8 they are maintaining. Okay. Last question. Okay. Shall I wait for syllabus to be completed to answer? Shall I wait for syllabus to be completed to start answer writing practice? Might be too late. Syllabus takes 7 months at times, 8 months, many subjects will complete it. 4 months, 5 months, whatever, at least one subject should be over, 4 to 5 months. Which subject is over, that you start writing. Okay. See, I can continue from here, but we've already discussed about mains answer writing. And if I want to start, I want to start properly. Take a break for 5 minutes. See, I know it is off topic, but I believe the last 30 minutes was useful. You need to know why you're learning certain things and how to write also. Take a break for 5 minutes. Okay. I know it's early, but still. We'll continue immediately after that. Okay, thank you. And there is one repetitive question: how to attempt this unknown question? I'll just tell you that. See, it's about what is the meaning of unknown. I will tell you. I'll just tell you that and do. Unknown can mean two things. Okay. Like you know nothing, you know something. Example, let's take what was like any problem I'm thinking, like very, very specific. What is, I think this is the word, PUSA decomposer. Explain its importance. Do you know what is PUSA decomposer? People listen. If you don't know what is PUSA decomposer, don't write the answer. Okay, you can assume decomposer now, okay, it will decompose, it will help to decompose, yes, but don't know what is it, better leave. Don't do anything. I'll give you one more question. This question 2017 mains. Don't exactly remember, but I attended this question. What are the features of National Nanotechnology Mission? Features of National Nanotechnology Mission. Then talk about the applications of nanotechnology. National Nanotechnology Mission, that year I did not prepare and go. Exact features I don't know. I did not know. Like this much amount is allocated or this much new nanotechnology centers are starting. These areas, safest bet is, okay, government has decided to improve the number of nanotechnology centers and testing centers or scientific research centers in India. In the budget, in the allocation for science, some more amount for nanotechnology has been initiated. Basic idea. If I write these things, examiner won't get angry. Correct? He won't get angry. It's not completely right, but it's not completely wrong also. Government will increase funding. Government will say there is more. India has signed memorandum of understanding with certain foreign nations for transfer of nanotechnology. Government will sign, no? That's a mission. But specifics won't be there. I will not write specifics. Because I don't know specifics. Simply if I write over 2,000 crore they get given for nanotechnology mission, that guy will get angry. Right? 2,000 crore, how will they get? What if it's only 50 crore government have actually decided? We'll have the key anyway. 2,000 crore is the entire answer gone. So write the answer which, like, if you know something, write the answer which does not make the examiner angry. People understand, they will give negative marks. They will give negative marks. And I know individuals also who have gotten negative marks. You can ask the seniors also. If you irritate them, they will put negative marks. Okay, don't do that. This I played like anything. Applications of nanotechnology is open question. Idella you can write. So understand, unknown na, know nothing, leave. Example. What is Rabindranath Tagore's example? I mean, Rabindranath Tagore idea about nationalism. History question. Rabindranath Tagore, big freedom, important personality during freedom movement. What does he think about nationalism? Simply, if you start writing your perspective on nationalism, this was said by Rabindranath Tagore, they will catch you. That's the irritating answer. But never irritate them, never make them angry. Go for safe answers. Okay, this is the right way to do it. You don't know, Prime Minister asks you something very specific. Don't know, say don't know. Simply say something, not a good character of bureaucrat. That's all. Okay, I believe you got the difference. Shall we proceed further? Yeah, innovative way of decomposing agriculture waste using a fungi. Today's newspaper, it is there. That's why I took from PUSA decomposer. Fine then. Now let's talk about climatic regions. So lesson plan, 3 climatic regions, but I'm pretty sure we won't be able to complete, but still. First climatic region is Savannah climate. Savannah or Sudan climate. So we're going back to Gocheng Liang again. Savannah, Sudan climate. So totally 4 climatic regions we have done. We've taken on equator. Okay, the equator is done. Desert Sudan, British was done, and Mediterranean was done. So these are the western margin climates. Okay. Now we are going to look at the central box, and this will be the continuation also. Even if today's class is over, next class I'll be continuing in this section. Is it fine? So these climates, the first one is Savannah. Savannah, Sudan is right here. This one, SAV or SUD, Savannah climate. Take it. Once you finish, you tell me. Huh? Now let's start with a map as usual. So where is my Savannah climate? Yeah. So if you note one thing carefully, you would find that it is not largely present in the Eurasian continent or in parts of your American continent. Savannah climate is mostly found in your Africa, your South America, and Australia because of limitations, land limitations, that's all. So first section, largest section of Africa. So, largest section of Africa. So if you think about the countries which come right here, not your exact Western African nations, but north of your Western African nations. You take your Mali, Niger, okay, Chad, parts of Mauritania. You're coming to eastern part of Congo, parts of Kenya, Ethiopia, Tanzania, Burundi, Rwanda, Uganda. You all remember all those countries, parts of Angola, okay, all that. So not the equatorial forest, but areas surrounding the equatorial forest again. You come to your South America, same thing. So this was my equatorial forest, this blue color shading area. That's my Amazon basin. So surrounding the Amazon basin, you take your llanas, okay, which is present in parts of your Venezuela. Okay, you take your Pampas. This is again just away from your Brazilian Amazon forest. So this is Brazil. Again, Pampas. Is it okay? So these are an elevated region. You're moving away. You come to Australia. Australia has an extensive region too, and that's northern part of Australia. This one. Northern segment. Okay. So what defines the savanna climate? Why do these regions have savanna? Now, within savanna, you need to get one basic idea correct. And that we will understand by comparing it with equatorial climate. I will compare and then show you the climograph. Because you look at all these climatic regions, they're periphery to equatorial. Like this is equatorial away from equator, this is equatorial away from equator, this is equatorial away from equator. So you're technically away from equator. That determines this rainfall pattern also. Listen. Equatorial climate, we'll compare and learn. Equatorial climate, there is no concept of season, right? No seasons at all. Every day is more or less one and the same. Every single day you get rainfall, very, very high rainfall. Because the area which experiences equatorial climate is between 10 and 10, right? So your sunlight is always focused on this region. So you get very, very high temperature, very rainfall, no concept of change at all. Okay. Now, when it comes to savanna climate, you are moving away from equator. When you start to move away from equator only, that is the time you will start to feel the difference between different months of the year. You're close to equator, every month is same. You move away from equator, then whenever your direct sunlight is over Tropic of Cancer, you will experience good amount of sunlight. And whenever your sunlight is to Tropic of Capricorn, now your temperature is going to reduce, is it not? So savanna climate or Sudan climate, experienced in regions away or surrounding the equatorial region, surrounding the equatorial climate areas. Is it clear? Here, the seasonal difference is noted. Seasonal difference is noted. Okay, because you're moving slightly away from 10 degree north and 10 degrees south. Once you move away, then definitely there is a difference between Tropic of Cancer Capricorn over its sunlight movement. Okay. Now, to understand the seasonal variation and how does my rainfall pattern occur, we'll go to climograph section. Ready? So let me go to climograph. So this is my climograph for the savanna climate. And if you look carefully, okay, it is in the months of June, July, August. That is my proper summer season. So June, July, August, I'm getting very good rainfall. Okay, why again? The rainfall in this case is not driven by my wind system. During my summer season, sun is there. Okay, so sun will give me high temperature. Surface temperature influences air temperature. Air will begin to vertically up, will start cloud formation. Due to cloud formation, there is rainfall. Yes or no? So you take the winter season, okay, you can call it as a cool season. When we use the word winter, yes, it is winter. The temperature is not as low as British climate. So you take the other season, the cool season is dry. So savanna is properly demarcated by a dry season, a distinct dry season. That's the word used in the textbook. Savanna has a distinct dry season because there is not enough temperature for providing rainfall. Summer, when temperature is there is convectional rainfall. Convectional rainfall. Is it clear? Convectional rainfall. So you have a cool dry season. Cool dry season. India, rainfall is governed by wind system. Wind moving in, wind reversing. Here there is no wind reversing. If you look at, yes, the concentration is more for 4 months. That is correct only. Good. Okay. If you're done, I'll go to natural vegetation, shall I? Fine. Let me go to natural vegetation right now. How does cloud seeding affect this range? That's an out-of-the-box question. We'll see it later, yeah? Convection. Cloud seeding, you use the word, you're talking about artificial phenomenon. Nothing natural there. So I don't know how the question is exactly relevant here. Let me come to natural vegetation right now. Natural vegetation, again, I'm comparing with the equator. See what happens. Equatorial climatic region, extremely high temperature, very, very high rainfall. Once there is enough amount of sunlight and moisture, plants will be able to photosynthesize more. That is why you have tropical rainforests. Talk about your savanna climate. Your temperature is high, but it's not as high as equator. Rainfall is present, but rainfall is not present for 12 months of the year. You get rainfall only between 4 to 5 months of the year. So compare and see. Okay, there is a reduction in temperature, so which means there is a reduction in rainfall also. So this initiates or this indicates that plants will not have very high productivity as they used to be. And that is the reason you take your natural vegetation, it cannot support a rainforest area. Rainforest, the biodiversity is very, very high. You have immense amount of species, so many plants fighting for space. But here, since temperature has become low, since rainfall has become low, you don't have that much level of plants. You will have savanna woodland or savanna grassland. You will see pictures, please wait. Savanna woodland, savanna grassland. Let's see the basic difference. What do you mean by woodland and grassland? Okay. Done? Yeah. So when you start from an equatorial region, equatorial climate, and you move to a desert climate, and you have savanna right here, the center. This is the change in natural vegetation. Starting from equatorial region to your desert climate, there is consistent decrease in rainfall. This decrease in rainfall will immediately affect your natural vegetation. In equatorial region, you have tropical rainforest. Tropical rainforest area, very dense. In desert climatic condition, as we saw yesterday, I believe, there is very, very low rainfall. That is why you had domination of thorn species, thorn varieties, thorn forest. In this region, two types you can divide. parts of savanna climate which are closer to the equator, right? There the temperature and rainfall are good enough to support trees. Okay, so that is why savanna woodland is present. Savanna woodland, good enough to support trees. You move away from the equator, okay, you're closer to deserts, rainfall is even lower. So this is good for savanna grassland, tall grass. Grass grows really well, tall. Is it clear? Tall grass. So sequential change you'll find. See, nowhere except for your mountain regions. Only mountain ranges will create clear demarcation between one side and the other side. Apart from mountains, any part of the world you go, there is a slow change in vegetation, sequentially. Rainforest, woodland, grassland, and thorn forest. So we just see pictures for this to get the idea clear. Then we'll proceed to economic development. So that's the Amazon rainforest. So let's talk about canopy. Yes, you've seen this picture before when we discussed equatorial climate. So you can clearly see how dense the forest area is, you know. The light penetration is extremely difficult, and each tree is competing for space with the other. That's how it looks in the equatorial region. Now, let's say it reduced temperature and reduced rainfall. You move away from equator, and you would get this. Savanna woodland. Now, I think the discussion or the clarity is much more easier. Okay, this is a picture which is taken, this African in Australian savanna. So this picture is taken from the ground level, but one basic difference you would find. See, the areas of your equatorial rainforest is so dark in certain areas because sunlight cannot penetrate, right? Okay, like even if it does, it's almost non-existent because you have so many plants and they'll try to capture as much sunlight as possible. So canopy is very dense and completely covered. You reduce rainfall, see what happens. Sunlight is like, it's just playing around. Okay, the entire sky is visible from here. And look at the spatial variation also, high spatial variation. There's less temperature, less rainfall, competition becomes less. Now, what happens if you even decrease rainfall? Well, this woodland, what you're seeing in savanna, will become something like this. Your grassland. Savanna, grassland. Yes. This is a wonderful picture. Smaller one, no bigger one. So here you might get only 1 tree or 2 trees and it's vast expanse of just golden grass. Okay. But finally, if you keep moving away, yeah, then you will end up here. Okay. So that's how things are in Africa. Okay, starting from the equatorial forests, you reduce temperature, rainfall. Okay, you go to your savanna, you reduce rainfall even further. You go to your savanna grassland, you reduce rainfall even further. Even grass doesn't grow. You might find patches now and there. That's all. Date palm. Okay. So is it clear? Shall we go to the next point, economic development? Ready? A consistent decline. We'll see in the Africa map once you've done. So now let's go to economic development. What do these people do? Well, 2 things. Again, what is given in the textbook, what is not given in the textbook. 2 parts. Economic development. See, there are several tribes who live in this region and 2 things are there. First is pastoralism. Pastoralism. See, pastoralism is livestock rearing, but please understand this is a subsistence level. This word is very important. Subsistence. And I think you mean subsistence is you're trying to feed only your family or only your tribal group. There is no industrialization and all that. Very basic level of pastoralism. You have several tribes in different parts of the world. A very famous tribe is the Masai Mara, Kenya. Masai tribe of Kenya. Regarding them, there is a description in your text, Goshing Leon. Pastoralism. Now, how have things changed and what are the problems or what are the issues in these two regions. To explain that, let me take two different continents. First, we look at South America. Okay. And for that, let me take you to Klimograph. So let's talk about this right now. See, 30 years ago, 40 years ago, if you look at savanna climate, it was not a very attractive region for doing plantation agriculture. Why? Plantation agriculture requires large amount of water. You can do it in a place like Indonesia, palm oil, high amount of rainfall. Okay, you can do it in a place like West Asia, Ivory Coast, Ghana, high amount of rainfall. You go with cocoa plantations, no issues at all. But once you have come here, since rainfall is limited, you don't want to go for extensive plantations. But with improvements in technology, with improvements in irrigation, with improvements in extracting groundwater, countries have started to slowly change. And one example you can definitely find in South America. Okay. And I'm talking about Brazil. Last 5 years, there has been a consistent increase in forest fires in Amazon forest, right? And whenever you talk about Amazon forest, people simply say it is due to climate change. Well, it's only part of the answer. This is my Amazon forest region, which I personally shade in red, and this is my grassland region. Please note, large sections of this region in Brazil is now being used for plantations, soybean plantations, soybean monoculture. Soybean plantations, soybean monoculture. Regarding this, we have detailedly discussed in map reading, I think. Why soybean cultivation? Soybean is an important livestock feed. Okay, and from Brazil, large amount of soybean is taken to China. China is driving global demand right now. US is a saturated market. China is growing. So, thing is, you will destroy your natural grassland habitat. Once there is destruction, naturally you begin to expand. Now, what is happening is this region is getting converted. Already the natural landscape is getting converted, and right now, this is encroaching into parts of Amazon forest also. So several forest fires which you find on the external parts of Amazon forest, it is usually done by human beings. Why are human beings doing that? You destroy a patch of forest, you get open area, and there you can try to cultivate more and more soybean. So this is with reference to Brazil. Okay, so right now there are environmental issues due to soybean plantations in the savanna parts of savanna climatic region of Brazil. So this is for your South America. You go to Africa, talk about economic development. I'll tell you the positive first, then I'll tell you the problem. If you've seen certain Discovery Channel and your National Geographic and or your Animal Planet, most of the documentaries will feature lions, leopards, cheetah, gazelle and all that. And all of these documentaries, or at least not all is a wrong word, most of these documentaries are shot in these savanna grasslands of either Africa, okay, or your Australia. Fine. And that is why in map reading you would have seen the two countries which are found right here, Ethiopia, okay, and Tanzania. In Ethiopia and Tanzania, a major industry is wildlife tourism. This is something which has changed in the last few years. Wildlife tourism. Okay, Ethiopia, Tanzania, map reading. Okay. Is it clear? So I just have one question. Simple. Between equatorial climate and savanna climate, which climate has high biodiversity? Equatorial, no doubt, no? Equator versus savanna, which is high biodiversity? Equator, there is absolutely no doubt at all. Very high temperature rainfall. If that is the case, why do most of the documentaries are not set in equator? Most of your documentaries, if you see, which are posted on YouTube or on the TV, it is done in savanna region. Why? Exactly. See, understand, it's not that savanna has biodiversity. The point is, equatorial climate, it is very, very difficult to shoot. Not just so many animals and birds, so many insects will be there. Insects will bite you. You'll get several tropical diseases also. More multiplication of bacteria, fungi, and it's very difficult to shoot in a dark forest area. In the open grassland, okay, zebra will be running, cheetah will be running, simply sit with the camera and then you can capture it. Okay, that is the reason. So it is more to do with the ease of shooting, ease of photography, rather than diversity. That's the reason savanna has. Okay, it's dense forest, so much easier to shoot. And people like lions and leopards. Equatorial forest area, many will not even know the names of several species. Now that's one good thing which is actually happening here. Now let's come to this region right here. based on the previous discussion, you would already know that this is my Sahara Desert. And you've already seen this earlier. This is my Sahel region. Remember Sahel from map reading class? And I would have told you Sahel region is a region which has problems of food security, malnourishment, and even Boko Haram, the terrorist organization, is actually operating in a northeastern part of Nigeria, spreading to three to four countries. See, currently this is a huge environmental issue because you have issues of desertification that is which is actually occurring in the northern part of your Sahel region, and several efforts are being taken, but this region is under severe ecological, environmental, and population stresses. You have high birth rate in this region because the poverty is very, very high. You don't have much economic industries also. And it's highly problematic region. This is what in news they call as sub-Saharan Africa. Sub-Sahara, that is immediately south of your Sahara Desert. Sahara. That's something which we need to counter. Okay, these regions. So economic problems and social problems in sub-Saharan Africa. Is it clear? Now should we try to finish Africa right now? Like it's not completely over. Mediterranean is done. Steppe is there. Steppe and okay, let me finish Steppe and then come try to put things over. Okay. Well, maybe I'll finish it off because you won't get that feel. You might be thinking you're just reading or... Just a second. Huh? Just hold on. Okay, if it works by any chance. Because since three climates are over, equatorial is over, savanna is over, desert is over, like you see a part of the world, you should be in a position to understand what it is. Then I'll go to Steppe. Steppe I can finish. Let's see for a few seconds. If it works, then it's fine. It works only if the net speed is good. Fine. Okay. People listen here. So in this African continent, you should be in a clear position to understand where your vegetation is dense, and as you move away, what happens. So this is my equatorial forest region, the dense region of Africa. Okay, so this is my equatorial low pressure belts. Blue doesn't work. Let me use black then. The equatorial low pressure belts. Okay, so you have your subtropical high pressure belt here, a subtropical high pressure belt here, right? And this is my trade wind. Trade wind. So since winds blow from sea to land, that is why you take this region. You have your Namib deserts and your Kalahari desert. You take your Botswana and Namibia. It forms as part of here. And you have your Sahara desert in northwestern part of Africa. See, the wind is blowing from land to sea in both cases. Land to sea, land to sea. I try to extend these trade winds. See what happens. Trade winds. You see that again, the wind is effectively moving from land to land. The water body of Red Sea is very, very small. So this entire segment is a desert. You can clearly see the sand extending for several regions. And this extends to this region also. The reason why, look here again, I continue with the trade wind system. You'll see that it just starts from Arabian Peninsula, again, effectively land to land. That is why this region is also a desert, including parts of Somalia. So you understood the desert part, right? So you go to the central region. This is the region where there is extremely high amount of rainfall. So this entire patch is my equatorial forest. And if you see the country names, yeah. To an extent. So this is my DRC, Democratic Republic of Congo, Gabon, Equatorial Guinea. And if you remember, the southern part of Nigeria, that's why I told you Nigeria is a split country. We need to speak about Nigeria, and I told you the country has very high population. So this is the Nigerian border. And within Nigeria, you have two problems. Like one part of Nigeria is experiencing high temperature, high rainfall. So this is economically well developed. The northern part of Nigeria is a desert. And this is where Boko Haram operates. Okay, it moves to Chad, it moves to Burkina Faso, it moves to Cameroon. Okay, it moves to Mali also. Okay, Mali, Niger on top. So you'll find Niger, you'll find Mali. So these regions have severe problems of food security. You come right here. This is where you have your cocoa plantations. You know, Cote d'Ivoire, your Ivory Coast, and then your Ghana. Fine. So the final wrap up is this. Wrap up on Africa. That's too big. Yeah. So equatorial climates, portions of West Africa, and the parts of your central region of DRC, desert climates, Namibia, Botswana, and this entire section of Northern Africa. And your savanna is in between. This is savanna. This one. Okay, it's not as dense as that. So this is what we saw in your GCL. So you need this to appreciate human geography, because they ask you a question on population density, they ask you a question on anything else, you'll be in a position to clearly demarcate and tell them, this is why you have certain population problems or climatic problems only in certain parts of the world. Okay. Economic development, anything specific for Australia? No, nothing. I think desert climate is mostly fine, because the reason is, again, it's an area which is mostly unexplored. Okay, you don't have a large population living in Australia. And if you remember the map reading session also, all your major 5 cities will be found in the southeastern side. That's why. The Great Green Wall is, yes, Great Green Wall being planned in sub-Saharan region. See, it's only about consistency in investment. Problem with African nations is there is high level of corruption. So even if funding is given by international organizations, they should use it properly. Okay. So I believe you're able to relate to it, what you learned in terms of both physical and human geography, how being where you're located will dictate the economy of a country. Okay, certain countries will be split. You can't do it. Same country has several climatic regions. It actually creates problems, no? Every part will have different climates, so different human geography also. India, you have several variations, so very diverse. Next climate is steppe. Number 2, I think we'll introduce steppe and some more points. Try to finish at least the climate part. We'll see. 7, 10 possibly. If we can complete this climate, it'll be good. Steppe climate is usually considered as the heart of climatology. Why? Heart. Why? No. Because it's found in the center, that's why. It is there. Steppe is here. STEPPE. This one. That's why it is called as the heart of climatic regions. It's heart of continents. Okay. Why is there so much civil war in Africa? It's not a geographical cause, political clause. I will explain. Okay. How can we relate in mains answer writing? That's why I told you, Ramesh. Mains answer writing, you can use these points if they ask about anything regarding civilian conflict or population variation or economic development. Okay, if there is any question on that, you can use climate as a factor, water availability, and if there is savanna also, there is at least tourism potential. You don't even have that. If you don't have minerals also in your country, what is your potential? Those are issues. So let's start with your steppe map. Steppe climate is here and here. Fine. See, a simple prelims question would be asking what is the names of the steppe grasslands in different corners of the world. I start from Eurasia. The climate gets its name from steppe grasslands of the Eurasia itself. So if you look at the countries will start in eastern part of Europe. If you remember map reading from Ukraine, Ukraine's major export would be sunflower and cornflower oil. Okay, the plain is very, very flat. So starting from Ukraine, it passes to the Central Asian countries. Okay, you take your Kazakhstan, your Uzbekistan, your Tajikistan, Turkmenistan, areas surrounding the Caspian Sea. So these are part of your steppe climate. And you have an isolated region in China, Manchuria. Coming to the western part in North America. So this is my prairies region. See, one of the most highly productive agricultural regions of the world is in North America, known as the prairie grassland. Very productive, very, very productive. Prairies, Prairies. Come to South America, it is called as pampas. This is found in the northern section of Argentina and parts of Uruguay. Basically, northern Argentina and parts of Uruguay, Pampas, P-A-M-P-A-S. You come to South Africa, it is called Veld. Veld is again, it derived from a Dutch word, Veld. It means grass, the southeastern part of South Africa. If you remember South Africa, it has small climatic regions. The southwestern part had Cape Town. We talked about Mediterranean climate, isn't it? Small section. So here you have your steppe climate, a very small section. And now let's come to Australia. And why Australians settled on the southeastern part? Australians settled in southeastern part of Australia because of Downs grassland. Much more bearable. Because this, asked a question, why aren't we concerned about Australia? This entire section is a desert. Completely gone. Northern part is a tropical grassland. Okay, again quite harsh. Okay, take here, steppe is much more conducive climate. You're moving away from equator. So this is Downs grassland. Is it clear? Now, what basic difference do you have between a tropical grassland and temperate grassland? We'll look at the climograph and then try to understand. Okay. Where is my climograph? So, basic difference is this. See, once you start moving away from the equatorial region, now the latitude is like 40 degree north, 45, 50 degree north also at times. Okay, 50 degree, yeah, 50 degree north also. Now, once you start moving away, your temperature becomes very, very low. Once my temperature becomes low, so does my rainfall. So look at the map right now. You take your summer season, months of May, June, July and all that. Okay, where your temperature is very, very high. That is the time where you get some amount of rainfall. See, here also there is convectional rainfall, but the convectional rainfall does not produce as high rainfall as equatorial climates or a savanna climate. It's even lesser. Why? Even if sunlight comes, sunlight is there, but sunlight doesn't have that much potential. Even if sunlight is present over Tropic of Cancer at 23.5 degree north, you are somewhere around 45, 50. Okay, even then sunlight will be less. So rainfall is still convectional. Rainfall is still convectional, same as your savanna. Okay, you will form clouds. It is convectional, but rainfall is less. Rainfall is less. Why? Because sun's insolation is reduced. In higher latitudes. This is what you learn as a relation between latitude and temperature. As you go away from equator, then naturally your temperature, your average temperature or mean temperature will decrease. Okay. So what we will try to do, we finish this point. Shall I proceed to the next point? We are going to compare northern and southern hemispheres in the same climate. Okay. Fine then. So this time I want you to look at the temperature graph alone between northern and southern hemispheres. Let me draw the line for you. Temperature graph. So if you see something, there is a difference. The range of temperature, that is, difference between my summer and winter temperature is very, very high in the northern hemisphere, but difference between summer and winter temperature is very low in the southern hemisphere. Why is the fact that northern hemisphere experiences very, very high variation? Why is it absent in the southern hemisphere? This is where we understand the concept of continentality and moderation of sea. Okay, so let me take you to Blackmoon. This also explains why the smog issue or the smog, smog problem is very much in Delhi compared to Mumbai, Kolkata and Chennai. Okay, let's take the continental condition or continentality. Yeah, spelling continentality, T-Y, moderation of the sea. I will take a location of my choice. So let me take an area. So this is my intended location, land. This is my intended location, land. Okay. Now, let me take a condition where land is surrounded by, or the location in this case is surrounded by land everywhere. Is it okay? Here it's much closer to sea. Now, how is this called as moderation effects? That is where you come to differential heating of land and water. Shall we start differential heating? Understand the concept, will give you time to write. Simple. Based on differential heating of land and water, their properties are different, and that determines when they will experience high temperature. During my summer season, my land will experience high temperature because land heats up much faster. Water will be at a lower temperature, right? So understand what happens. Summer season, the location is hot. Why? Because it is land. This will also be hot. This will also be hot, 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 hot. Delhi will experience very high temperature because it is surrounded by land mass. Fine, your summer temperature will be 45 degrees, 46 degrees also. You come here, yes, there is high temperature, but understand that is only for land. During my summer, as you know, the water's property is different. Your water will be at a lower temperature. Is it okay? So now, this high temperature area is surrounded by two different areas of low temperature, which means wind circulation will be there. Okay, so due to presence of wind system, your heat energy will get dissipated. The land and sea will start to exchange heat, and you will prevent the temperature from becoming very, very high. Okay, let's take a condition of winter. Okay, in the winter conditions, land will be colder. It loses heat much, much faster. Not just that location is colder, everywhere it becomes colder. Down, down. That is why Delhi experiences sub-zero temperatures very, very easily. Okay, the temperature goes down 0, goes down -1. November already, November is going to end in 10 days. Okay, in December, the temperature will be, already the problem would have started. Okay, it's freezing out there. Fine. Now, reverse condition. When land is cool, okay, sea temperature will be warm. So again, there is heat exchange. There is more possibility of heat exchange. Okay, heat exchange, heat transfer. So you enable heat to dissipate out. That is why the difference between summer and winter will not be very, very harsh. That's due to moderation of sea. That is why localities closer to sea are much more climatically beneficial. You go to an interior location, then summer and winter you need to have better adaptability. It's very, very harsh. Is it okay? That's the reason. So that is continentality. Now, how is this applicable? Let me show the map, you'll understand. So shall I go to the map section again? Just tell me. Go to the map, steppy map, and see how this applies. Why in Northern Hemisphere there is more continentality? One more response, I'll proceed further. Okay, how is this related to pollution? Simple, man. I'll give you a simple idea. Pollution, don't think too much. Environment, because environment you will learn in detail about Delhi smog. I just don't want to give too much information because our discussion is different. Temperature is low, man. 0 degree, sub-zero degree, which means surface temperature influences air temperature. So air, instead of rising, air will begin to stay down. Surface temperature cools air, air stays down. Morning you're going, putting key inside, scooter. Start scooter. Air will come out. Rise nicely. Air won't leave. Air will stay there itself. Think about how many automobiles are there in Delhi. Everyone starts car. Carbon monoxide comes out. Nitrous oxide comes out. Everything will stay there and a surface temperature is low. Air will settle down nicely. Temperature is high only, they will rise up. So all your pollutants will just remain closer to the surface. Because naturally the environment is cooler. See, they are pointing out stubble burning. Is stubble burning an issue? Yes. But understand, even if stubble burning is stopped, let's say no farmer in Punjab and Haryana is doing stubble burning. But still, Delhi's pollution problem will be higher compared to a place like Mumbai. Because Delhi is continental, even if stubble burning is stopped, complete solution is not there. Because of continentality. Is it okay? Pollutants begin to stay down. Mumbai, exchange will be there. Kolkata exchange will be there. Chennai exchange will be there. Bangalore problem is there. Bangalore problem will come. So why more continentality? Because in Northern Hemisphere, the land, the discussion is slightly away from sea, right? They're surrounded by land, surrounded by land. You take here, everyone is closer to water. Pampas close to water. Belt closer to water. Downs also closer to water. That's the reason they escape. Is it okay? Now coming to your natural vegetation part, a simple statement. Okay, I'll just finish it off. 10 minutes. Natural vegetation. Short grass. Temperature is even low. Rainfall is even low. Equatorial climate rainforest. Then you moved away from equator, it became tall grass. Now, temperature and rainfall can't even support tall grass. Grass will grow, rainforest. Tall grass in savanna, short grass. That is my natural vegetation. Rainforest. So, equator, tall grass, short grass. Moving away from equator. Decrease in temperature and rainfall. Now, what is my economic development? We will see that. In all parts of, on most parts of the world, even in Eurasia, it is caught up. Most parts of the world, there is one industry which is very, very dominant. And what is that? Economic development. Extensive. Major industry here, extensive. Wheat cultivation. Extensive wheat cultivation. What we saw in savanna climate was mostly your, again, I was talking about tribals, no? So what tribals were doing is subsistence agriculture, just for their family. When you talk about extensive agriculture, it's about the size of the area. You're talking about hundreds and thousands of acres, very, very large area. You're not concerned about productivity too much. You want more production, not just productivity. It doesn't matter if you're not getting the not extracting the highest efficiency from your land. That is intensive. Extensive is the scale or size. It works like this. Along with wheat, the peripheral crop which is cultivated is corn. And corn is fed to livestock, like cows, pigs. So wheat is something which humans consume. Don't come and fight, say, I also eat corn. I also eat corn, and I also eat maize. I also eat soybean. But soybean and corn is mostly fed to livestock. So cows and pigs. Once cows and pigs eat, what will they become? Fat. Once they become fat, kill them. Okay, so this is for meat industry. This is ranching. That is production of livestock along with farming. Farming and livestock production. Ranching. This is a very big international industry, people. So many multinational corporations are involved. And United States is the big daddy. Okay, USA. Corn, livestock production, meat production. You slaughter them, cow slaughter, pig slaughter, ranching. The process is called ranching. Big industry. Is it clear? And it differs between different countries. For example, in United States, there is more beef production. You go to Australia, there is more sheep, more goats. Okay, so the animal might differ in different parts of the world, but the idea is same. So we'll just get the idea or meaning of this extensive wheat cultivation and ranching farms. Just 1 to 2 pictures to understand the scale. Okay, then we'll go for open the session for discussion. Okay, just let's see whether you can answer this question. Anyone tell me, you know Superman? Superman comes from which state of United States of America? According to the story, where does Superman come from? Anyone? Superman belongs to which state, people? Come on. At least Google and say, Superior. Ada map reading. Which state of USA? According to the story. No, Gotham is for Batman. See, I'm not talking about Metropolis. Superman is from one state of United States. Yaar comics fan illaya. Comics fan illaya means no comics fan is there. Super, one person is there. Kansas. See, if you've seen Superman film, Man of Steel film you have seen, did Superman have any neighbors around? Really? Or his house will be very, very free? If you think properly, Superman's house will be something like this. Wait, let's see if I type house knight comes or not. Kansas house knight goes to Kansas House of Representatives. Let me show you wheat farm. See, good thing Superman fell in a place like this, people. See, you cannot even imagine the level of machines they use in a place like Kansas. When I discussed map reading United States of America, I spoke about eastern coast of USA. I would have spoken about western coast of USA, but we never spoke about central region of USA. Why? Because central region, people are not there. Okay, they only do extensive wheat cultivation. No one will be there. Okay, see, one farmer, look at this, a very good picture. One farmer will control acres and acres of land. If you're a farmer in United States of America, don't think like our farmer. Ranching now, 4 goats will be there, or cow will be there. Ipdi 2 acres. You're 200 acres here, 200 acres here, or 100. Okay, you'll be controlling or 3 to 4 machines. Only 2 individuals or maximum 3 individuals will be working 300 acre farm, 400 acre farm. Okay, everything will be controlled through machines. Okay, and extensive usage of machinery. See, the farmer, not like our method of agriculture. It's very, very extensive. Just to show you the scale of farming, you should understand what you mean by extensive. Very large area. Superman comes from this state, according to storyline. Is it clear? And just one more picture. Just hold on. I don't know where it's available right now. Okay. Very extensive regions of ranching farms also. Is it clear? You see those taglines? So you might have seen it in certain pictures. Sorry, certain movies. Okay, the cows having tags. This one. Okay, to certain scene, certain films. It comes from there. Is it clear? Just one more additional point. This is practiced in most parts of the world. Most parts of the world, I mean. It's there in United States. It's there in Argentina. It is there in South Africa. It is there in Australia also. But you take this region, Eurasian steppes, it is not that developed well because they were associated with Soviet Union until 1991. Until 1991, the 5 Central Asian nations, Kazakhstan, Uzbekistan, Tajikistan, Turkmenistan, and Kyrgyzstan, they were part of Soviet Union. After Soviet Union disintegration also, since 1991, the governance is very poor. Like the government has not really given enough incentives to farmers, enough methods to farmers on proper economic agricultural methods also. These are very poor countries in terms of per capita income, and governance is very poor, meaning last 20 to 25 years, only single dictatorship is running in several parts. Okay, autocrats. Few families will control the entire country. But potential is there when it comes to Eurasia. Currently, here what industry is present is, which is to an extent remunerating for Eurasian steppes. Any of you, your friends whom you know, have went to Kyrgyzstan, Kazakhstan? Wonderful places for tourism. Scope is very high. Extensive plains. No one will be there. Your life will be very peaceful. So they are trying to promote tourism. But agriculture is more of secondary industry. Maybe parts of Eastern Europe, like a developed nation like Ukraine, they do go for corn and sunflower oil cultivation. And it merges in. So here, parts of Europe, you do have wheat cultivation. Parts of Europe, wheat is there. That's what we saw in map reading. Take parts Belarus, Ukraine, and southern Russia. But others, they still haven't explored the potential. So that ends the discussion for your steppe climate. Okay. Cotton is also grown in Turkmenistan, Uzbekistan. Correct. Right. It will be lonely. You can be peaceful, right? There's no one. If you want to throw a ball, I can simply throw the ball. It won't hit anyone. Chennai tried doing that. Okay, before it hits the ditch, it will hit 4 faces and all 4 faces will shout at you. Can't even play in Chennai, no? Too many people. Survival. That ends the discussion for your steppe climate. See, now climatology is almost over. Okay, like the cyclonic part is the one which is the largest extensive discussion. So we finished both of them. Climatic regions, we still have 5. Siberian, tropical marine, China, Laurentian, and Tundra. That's an integrated part. So after this segment, we have thunderstorms. Thunderstorms is again a 35-minute topic, 30 to 35 minutes. We have local winds again 40 minutes, and then urban climate, 15 to 20 minutes. So one class, remaining climatic regions, one more class. So 2 more classes will finish climatology. So what I need is this for geography, finishing geography. 2 classes for climate, 2 to 2.5 sessions for geomorphology, 2 sessions for oceanography. If I need, maybe along with this, I need an extra 1 hour. So 6 more classes I'll finish. Okay, we don't know how long or how sooner. Okay, possibly by December end it's done. December end, like every day I won't show my face. Don't worry. Like now and then I get a chance. 2 sessions now and then. Like every Sunday I come 2 to 7:30. 3 weeks it'll be done almost. Okay. Happy? Yeah, because only then environment can progress. No, environment started for your batch. Maybe for B3 they might have started. So any slide request is there. You give me the slide number. Turkmenistan is having 4th largest oil and gas reserves. Yes, Ramesh, we saw that in map reading. We did. Okay, TAPI project. The TAPI project is not undergoing because of Pakistan. Location is the issue. Kazakhstan has uranium reserves. Yes, so mining is an industry, but they've never reached their potential. El Nino and La Nina. I will teach you under oceanography. You need oceans and atmosphere to understand El Nino. Slide 32. Slide request, send it through chat box. Any doubts are there, you please raise your hand. I'll ask him to enable. Slide 32, 33. Hand raise irka? Hand raise enable பண்ணுங்க.
Good evening, sir.
Good evening, ma'am.
Sir, my doubt is regarding how to draw the climograph, sir. Suppose easily in the paper for climatic region.
Climograph simple.
Yeah.
What you shouldn't do is need not write January, December and all. If you want to show summer rainfall, example, summer rainfall, na? Simply say summer, rainfall is high. This will be enough. Y-axis la rain.
Sir.
This will be enough. The exact details are not needed. Temperature you want to show. You feel like showing temperature. Simply write a temperature. Okay. Jan to December you put one line. That's all. 3 seconds diagram. Beyond that, don't spend time.
Okay, sir. Okay. And one general question, sir. What is the difference between melting and thawing, sir, of ice?
Both the same. Both the same.
Both are same. Okay, sir. And one more doubt. Can we try for TNPS exam also, sir, based on this preparation? What is your opinion, sir?
It is not possible because for Tamil Nadu Public Service Commission, you need to learn specifics of Tamil Nadu. So with the same material, you can't write the exam. Extra material you need to prepare. That is specifics to Tamil Nadu. It will again take 2 to 2.5 months extra. It's not that it's not completely waste. Like world, whatever things you have learned, India, what you have learned, like Indian history, if you have learned, yes, useful. But Tamil Nadu history, Tamil Nadu geography, extra you need to concentrate. It'll again take, I would recommend extra 2.5 to 3 months of preparation if you're writing. Jan 3rd, you're writing exam. Jan 3rd, Jan 4th.
No, sir. No, sir.
Okay, fine.
Just asking for general opinion.
No. If you're preparing, you need more time. I'd say rather don't waste any attempts without preparing. Okay, it will need preparation. This is not enough. That's why.
Okay, sir. That's all, sir. Thank you.
Yeah, good evening, sir.
Yeah, hello, go ahead. Krish.
Sir, one small query here. Is there any jet streams from east to west, sir? Because
Any jet streams?
we saw everything from west to. Why so? Actually, why all the jet streams are from west to east?
There are jet streams which move from eastern side to western side, but those are local jet streams. You take India, there is an easterly jet stream itself. Easterly jet stream occurs in the months of June, July, August, and September. Okay, so we do have. It's over India.
No, sir. But in case of the high altitudes, why is it from west to east? Is there any specific reason for it?
There is a specific reason. I'll show you. Hold on. See, the person who asked for slide number 13, have you copied? Slide 13, done? Yeah, fine. See, let me take an air column. 0, 30, 60, 90. Air column. Air column meaning a column of air, that's all. I'll take an air column here, which is located between 30 to 60 and one located between 60 to 90. Now you tell me why the air column is more expanded, why the air column is more short. Air column is short, air column is more tall. Between 30 to 60, 60 to 90. Any reason for this? One word
okay,
answer.
sir, I can give a try.
One word answer.
Maybe the pressure, air pressure.
No, something else. One word answer.
Convergence of air.
Air column, temperature, that's all.
Yes.
You don't think too much. That is why tropopause is inclined like this. Okay, equator there is more expansion of air. Polar region, as you keep on moving, the expansion will decrease. Is it okay now?
Yes, sir.
Yeah. So now, do you see a difference right here? Near the tropopause, air can move like this. Yes or no? Able to visualize?
Yes, sir, I can see.
Yeah, able to visualize. See what happens. This is equator, so south. This is south of equator, south. This is north. I'll draw this diagram. South, north. Now, in the upper atmosphere, not the lower level. The video is getting blood, just keep following because exacts are not here. See here. Upper atmosphere near tropopause, it is moving like this, isn't it? Now, this is due to pressure gradient force. High pressure, this is at low pressure. Near the tropopause. Just flows down, pressure gradient force. Now this will be deflected towards the right side. When you deflect it towards the right side, it's three-dimensional. I can't show it on the board. It'll flow like this. Towards the camera, towards you. You get the idea? Like this.
Yes, sir.
It moves from western side to eastern side. See that? It's moving towards east. You get the idea why west to eastern side? Yeah?
Yes, sir.
Yeah, that's what I'm talking about. That's why western side, eastern
That
side.
is
Yes.
right.
Same will be applicable for your southern hemisphere also. Southern hemisphere, Coriolis force is left side. But again, this everything will change. This will be inclined like this. So automatically same philosophy will apply.
Okay, sir. North Korea, okay, I have gone through the climatic regions. Okay. What kind of questions I can expect out of it, sir, in terms of main?
See, climatic regions, they won't ask you like, explain this climatic region. No. Like, they will ask you with reference to economic development, access to water resources, and what is the current scenario, environmental impact and all that. Those questions you can actually get. See, the textbook will simply not get repeated. For example, how does agriculture vary across the world? Simple question. How does agriculture vary across the world? There you need to understand climatic regions. So you need to take what type of agriculture is done in equator, done in savanna, done in steppe, done in Siberian climate and all that. Meaning makes sense.
Yes.
Yeah. So how does rainfall
Yeah,
vary
got
in
it.
different parts of the world? So it's that you learn everything and the questions will be general and you get points from every climatic region. It's not that I learn 3 pages, I get question. That won't be the case.
Okay, sir. Last one. I have seen a question related to the coral reef. What are the? Is it related to environmental or it is related to geography?
See, again, the right way to understand is this. Geography and environment is taught by 2 different faculty because the scope of questions has increased. Before 2013, you do not have general studies paper 3 as environment. So I will teach you coral reefs from the geographical perspective, where coral reefs are located. And in your environment class, what is their environmental significance? When you write answer, you combine both of them and write. You will never find answers in a single textbook, single notes. You get the idea?
Yes, sir.
Yeah, so you learn
So
from both
the
and write a combined answer. That's all.
So the majority of the questions will be related to application oriented, not based upon the textbook oriented, right?
No question
In
will
case of-
be textbook. Yeah, see, no textbook will give you answer. That I assure you. If textbooks give answer, then everyone should get service. Right?
Okay. Thanks.
Sure. Slide 9 finished. Several requests of slide 9 already asked. Make it faster.
Good evening, sir.
Good evening. Go ahead.
Sir, I didn't follow this concept, sir. So why the moderating effect of C was introduced?
Oh, hold on.
Like I couldn't follow that.
Okay, hold on. I want to talk to you. Hold on. Slide 9, have you done? Just a definition. How long? CIN 20666034. Make it faster. Okay, thank you. Okay, do you remember differential heating of land and water? The property is there in your notes?
Yes, sir.
Okay, just take
Yeah,
the property.
that's there, sir.
So my question is simple. Do you have any difficulty in understanding that land and water heat up differently during summer and winter?
No, sir. It's
No, no.
absolutely fine, sir.
So it's like this. One body is hot, one body is cold, one body is hot, one body is hot. In these two cases, when two different bodies experience different temperatures, there will be heat exchange. Once there is heat exchange, if I feel excess temperature, I can give it to another person. Correct?
Yes, sir.
That is why during summer season, land doesn't experience very high temperature. That's why summer season the temperature doesn't shoot up. Here, that is not the case. Summer season, if Delhi gives it to Gurgaon will give it to Delhi. If Delhi gives to Faizabad, Faridabad will again give it to Delhi. Every city will again give back the heat to Delhi. So temperature will shoot up. Is it clear?
Yes, sir.
Same thing for winter. Winter condition reverse. Cold. If I go and ask my friend money, friend doesn't have money, friend scolds me. All my friends don't have money. Here condition will reverse, that's all. So your sea becomes hotter, your land becomes cold. Now sea will give money to land. So again there is heat circulation. Winter temperature won't fall. No one is poor right here. Here everyone is poor or everyone is rich together. Is it okay?
Yes, sir.
So this
Sir,
is
but my doubt is,
severe summer, very high temperature, severe winter, low temperature. Here there is no severity.
Yes,
That's
sir.
it.
Sir, but my doubt is like why this concept was introduced in the steppe climate.
Why the
So I couldn't follow that.
Because steppe climate has two different variations in climograph. Look at here. Northern hemisphere, high range of temperature. Southern hemisphere, low range of temperature. Yes or no?
Yes, sir.
Because northern hemisphere, hold on. Northern hemisphere, countries or the regions which experience steppe climate are continental, away from sea. Continental, away from sea. That is why high range of temperature. You come to your southern hemisphere, closer to sea, moderation. Is it okay now?
Yes, sir. It's okay.
That's the low range. That's why
I got it,
introduced.
sir.
Okay.
Thank you, sir.
Sure.
Good evening, sir.
Good evening, ma'am. Go ahead. Yes, ma'am.
My doubt is regarding classification of air masses based on the temperature.
Okay, ma'am. Yes. Like you're talking about warm and cold air masses, no?
Sir.
Warm and cold air masses, correct?
Yes, sir.
Okay. Where does the
whether based on the place where the air mass originates depends on that.
This is after movement.
Yes, sir.
Let's say air mass is formed over Siberia. I'm not talking about that surface. After forming on Siberia, let's say it moves over Japan. Japan is surface, you compare it to their mass. That's like that. China surface, compare it to their mass. After movement, okay? Ma'am, are you there? Maybe the
yes, sir, I got it. Thank you.
Okay, got it. Fine. Okay.
Hello.
Hello.
Yeah, so I just wanted to know from all the jet streams and all, from which part of NCRT should we prepare for the jet streams and cyclones?
Actually, the content which we saw in jet streams, it is actually not there in NCRT. If you want any further information, you want any data, for example, let's say kilometers or what do you call velocity and all that, maybe that extra amount of data alone, you can just search in the net, just velocity and kilometers. Okay, apart from that, the content discussed here will be enough. You take this part, for example, where we discuss the fast moving, slow moving thing. This one, right?
Yeah.
So even in advanced textbooks, it's not given like this, convergence and divergence. Okay, so this is convergence and this is divergence moving out. Forgot to write that word. Convergence moving and divergence moving out. You'll find a different diagram. So you just stick with what is given in class. You just concise it for exam purpose.
Okay, sir. So yesterday's and today's topics, mostly it wouldn't be there in NCERT is what.
I mean, it's not that it completely won't be there. You take chapter 10, the discussion will be there, but several sections have given extra in apart from what is.
Okay.
Okay.
Thank you, sir.
Nisha. So I think I have only two more questions. One is that Africa question, slide 7. Oh, slide 11, slide 32. Slide 7. Okay, I'll just finish that and come to 32. 7, not much is there. See, I'll answer the Africa question through audio, and if you understood through audio, just tell me yes, okay? The person who asked the Africa question. See, African regions have civil wars because when the countries were actually born, let's say a country like Burkina Faso is created, or a country like Zimbabwe is getting created, those countries were not demarcated after a proper national movement. They were not demarcated based on at least a certain level of homogeneity. Only if a certain level of homogeneity is there, a country will remain together. For example, let's take India. There are several factors, even though there is diversity, several factors which connect Indians together. Fine, there was a national movement which started in 1885 and it went on till 1947. So extensively, an idea that India as a nation is properly implanted. Okay, there was same administration, same laws, same court system, and irrespective of whether it's continentality in Delhi or it is going to be moderation in Chennai or Mumbai, everyone are affected equally by monsoon climate. So monsoon is kind of what do you call a line which connects all of us. You can never leave. So there is this level of homogeneity, right? Like even if you take languages, there are so many languages, but languages are again one way or the other they're related. Now, when I demarcate a boundary, I want to make sure either in terms of language or in terms of culture, the area should be homogenized. That is when people will stick together. They will stick together as a country. You take Africa, the way they divided the political boundaries is not based on any level of cultural homogeneity or linguistic homogeneity. The boundaries were demarcated only based on political extent. Example, let's say France has colonized this entire region. Northern Africa was in control of France. For French administrative purpose, France would have simply divided the countries like these. When French left the empire and went, each of them became independent nations. That's all. Okay, let's take about Congo. Why do we have a country like Congo? Simply because Congo was under the control of Belgium and then Congo broke down. Why did we have a country like Sudan? Sudan broke down. That is why there is constant civil war. So every country you take, there'll be complex language, complex ethnicity, complex tribal group also. Complexity is not a problem. India survives in spite of its complexity. But India had a proper national movement. You had it for 70 years. See, people criticize our national movement. You know what they say? They say that, Britain lost the war in 1945. That is why they gave independence in 1947. People say this. This is true. I don't oppose this. But if there was no national movement, and if Britain had given independence at 1947, till today, India will be in civil war. That would have been the problem. That people don't realize. That is the success of Gandhi. That is the success of the freedom movement. Made sure, our freedom fighters made sure that they integrated. Okay. The people, you criticize, see, it's not based on party. It's never based on that. All the freedom fighters, be it Nehru, be it Patel, when they took power in 1947, they fought in the freedom movement for 25 to 30 years. They know the pains, they know the struggles, and back then they really wanted to construct. Things have changed. It gets changed over upcoming years because as the time progresses, people have no connection with the independence movement. You take United States, it's been more than 200 years since independence. So now they look like jokers, those who got independence. But those who got independence, they really wanted to make change. They really wanted to things, improvise things. Is it clear? Slide 32. Okay. That's why the freedom movement is. So no freedom movement in Africa or no consistent freedom movement in Africa. That's reason number one. This is slide 32. I think I've showed you already. Okay. What is the reason for cold front to be steep? One word answer is this. Cold front, as it moves together, its kinetic energy is less between different layers of air. So naturally, cold air begins to settle down. So they're densely packed. So when they move together, when they move in one direction, they'll move together rather than spreading in different directions. Is it okay? Is pollutant spreading good as a place where high concentration? Is there pollutant level will decrease? Pollutant spreading good. I don't understand the question. Is pollution spreading good? Okay, if the question is regarding summer season, air will rise, pollutants will leave. Yes, summer season there is more vertical convection, so pollutants will leave the system. If you generally ask, pollutant spreading is good. For the region which is a source of pollutants, it is good. Pollutants, you don't want to stay in the same place. Okay. What is the conclusion mentioned with treaties provided for mains question? Like, it's the basic ones, IPCC, Intergovernmental Panel on Climate Change, UNFCCC, and Paris Climate Agreement 2015. You learn this in detail. I've just given these lines. Don't worry, learn this in detail under environmental conventions. So shall we close the session, people? That was the last one.
Can you hear me, sir?
Tell me, last doubt.
You have answered my question, but I have a feedback. The video which has been uploaded in the portal, I see that there is a missing. No, can't you hear me, sir?
You can go ahead, ma'am. Tell me.
Okay, the video which has been uploaded in the portal is having some. I mean, though it has been compressed, there was some slides or some part of the session has been missed, like 15 to 20 minutes. That from 31, it has been jumped to slide number 42.
Tell me the date.
How can we approach 1st of November?
It's November. Okay, I'll keep this in mind. Okay, what topic did you miss?
The climate regions, equatorial and followed with that. I don't know what is there.
Yeah, fine. You've seen the entire video?
Yeah, sir. I have gone through the entire video. So it was 2 sessions. For the first half, it was okay. After the break, we have been missed with around 15 to 20 minutes. I'm pretty sure that it was 12 slides has been missed.
So I'll do one thing. So maybe next session I can close by half an hour early, and equatorial climate maybe. In case you've missed, I'll discuss with them. Let's see whether we can solve this issue. I'll just look with them. If not, I can just one climate only, and I can revise faster. So my recommendation would be you read the textbook. I think textbook should be helpful.
Sure.
I'll just revise it faster. Is it okay?
Yes, sir. And also if the video, I mean, if they have provided me the link for the video rather than they are putting it in the portal, probably I would get that 15 minutes even. So can I drop in an email to you so that you can support me?
Yeah. I'll try to I'll inform the issue, so they should get back to you. If they don't get back to you, read the chapter. Okay, because other climatic regions, you know the approach, so you can read the chapter. I will give an overview of 10 to 15 minutes in the next session. I'll just keep this in mind. Okay, so you can try to match what you've learned as content in the book and what discussion goes in class. Is it okay?
Yes, sir. Yeah. And the last one is about the daylight saving. I'll just put a reminder to you.
Yeah, sure. Okay.
Thank you, sir.
Yeah, sure. Thanks. Reason for warm front to be gentle. Yeah. I asked you to raise hand, no man. So many questions are coming right now. See, if you raise hand during the conversation, we'll be in a better position to sort it out. I will repeat the same thing again. Warm air, more kinetic energy. It won't settle down. Cold air settle down. That's known as packed. The layers can't move faster. Here, more kinetic energy is there. The molecules will be able to move fast. That's all. October 25 also. Okay, October 25, November 1st. You've raised your hand, I could have given a better explanation. I would know where the doubt goes on, man. I told you, told you to raise, and I was waiting so long. Can you repeat what topics we left in climates? 5 climatic regions, thunderstorms, urban climate, local winds. That's all. Okay. The 2 sessions we should wrap it up. Okay. So at least now shall we close the session? Fine then. Thank you. Hopefully meet you for next weekend. So 6 classes, I think we can wrap this up. Bye.